Okay, we are live and welcome to the 2024 Algebra 1 STAAR exam review. And for this live stream, I'm going to be going through the Algebra 1 test from May 2015. And I do have a link to this test in the description for the live stream, so you could download it or just open up the PDF and follow along as I go through the questions. So for the calculator portion here, I will be using a TI-84 Plus CE. I am going to reset this second memory 712 and just show you the settings I'll be using here. So I would switch the answers from auto to decimal, and I will put the stats diagnostics on here just so that if we have to write the equation of a line using the calculator, it should be good to go. All right, but at any point, we can bounce back and forth between other settings. So welcome aboard to anybody who has signed on. And yeah, we're just going to get rolling here. So, as always, I encourage people to talk in the chat and to ask questions because I will be going through these questions. But if you have any specific questions, I am happy to answer. So this test is pretty long. It is 54 questions, I believe. Let me just double check. I did, yep, 54. So we'll be here for a little bit. But I'll try to show as many, the most efficient solutions that I can. And I'll also show you like heavy algebra solutions too, because this is an algebra test. So I'm not just going to be doing calculator magic the whole time. Okay, so first up here, we have the scatter plot shows the number of visitors to a beach each day and the high temperature in degrees Fahrenheit for that day. Based on this scatter plot, which statement appears to be true? So for this one, I would say your best bet is to try to draw in the line of best fit. So for this one, if you have, a ruler or even a student ID, you could use this and just do your best to just draw a line that goes through all of the points here. So there is a non-linear correlation. Well, this one here, I would definitely say there is a linear correlation because that line that I just drew does capture these points pretty well. You see the points are pretty close here. If the points were all scattered about like this, then there would be no correlation, or maybe they would form an exponential curve. So then it would be nonlinear, but the points here are starting to gravitate towards a straight line. So A is out. There's definitely a linear correlation here. So then next, we have when the high temperature is above 100, okay, so above 100, fewer than 150 visitors are expected at the beach. Well, here, 100 is over here, and it's trending upwards. So the higher the temperature, the more visitors there are at the beach. I wouldn't say fewer than 150 because 150 is over here. And you could see that fewer than 150 would be around, let's see, 80 degrees or less. Then we're starting to go under 150 visitors. So B is also no good. Now, C, there is no correlation. This is not true. There is a linear correlation here. So just by process of elimination, choice D is it. But now if we really just zone in here, between 75 and 90 degrees Fahrenheit. So I'll just look over here, 75 and 90 degrees Fahrenheit. So there's 75 degrees and 90 degrees Fahrenheit. So let's make that a bit neater here. So if we look between here and here, let's try that one more time. Okay, this is better. The points that we are looking at here, all of these points, we have more than 120 visitors are expected at the beach. Well, this is good because you see 120 is over here. And all of the points in this space here are above that dotted line. So choice D is definitely our answer. All right, moving on, question 2. Question 2, I thought right away, like they were really challenging students here. This was like definitely a bit abstract to think about. So for this one, you can do the algebra yourself, but honestly, you're going to be dividing by $3.49. So I think your best bet here is to honestly use the calculator. But the concept behind this is a man bought X boxes of donuts for $3.49 each. So here, I would say we're looking at the total bill. Okay, so the total bill would be $3.49 times X, where X is the number of boxes of donuts this man is buying. And he pays with a $50 bill and he receives the correct amount of change. And so here we go. To describe the change is 50 minus the total bill. Okay, so he pays more than the total bill, but then when you subtract the total bill from the $50, that's the change that this man is getting back. So here, if he received more than 10 but less than 20, which inequality represents the number? So for this one, what I would do is now switch over to the calculator view. Okay, and I'm going to type in the equation that I just wrote here. So if we look, and I'm just going to make sure that this calculator is lined up properly. So let's bump it up to here so we could see a little more. Okay, so we have y equals, and we're doing 50 minus 3.49 times x. And now I press second graph to go to the table. And notice the answer choices go from 8 to 9 to 11 to 12. So I'm just going to scroll down to this neighborhood here. Okay, just to capture those values. And this is what I'm just going to focus on to answer this question. Okay, so this is the stuff that we're going to need to answer this. So now let's think about this logically. So if the man buys, let's see here, x equals 8. If the man buys x equals 8, and let me just see right here. All right, now we're back. Okay, so x equals 8. The change, so this is a function that'll tell us the change. The change is going to be y equals 22.08. But our goal here is for the man to receive more than 10 but less than 20. This is not less than 20. So you see, this one is already out. So x equals 8 is not part of our solution set. So for this one here, we could eliminate g and h. But now if we look at x equals 9, see x equals 9 is going to give us y equals 1859. Okay, which is more than 10 but less than 20. So this one is good. If we look at x equals 10 is also fine. And honestly here, I could look at x equals 10, but notice that f and j differ by 1. F says to stop at 11, j says to stop at 12. So let's check out what's happening here at 11. And really, we just have to check 12, but whatever, we'll just go through this process. So x equals 11, we get y equals 1161. And if I go one more, x equals 12, then the change y is equal to 812. And notice that this one here is less than 10. $8.12 is less than 10. We want it to be more than 10. So this one is out. So it looks like just between 9 and 11. Okay, this is the way here. I would say this one, though, for sure, the calculator is your best bet. The real challenge, though, is coming up with the function yourself for the change. Okay, this represents the change as a function of x. Okay, so as a function of x. Okay, and if you want to name this f of x, you can. You can say this is equal to f of x. You could say it's equal to y, but it is a function. Cool. So yeah, I thought that, you know what was like a little bit cruel about that question? Like the questions get easier later, but they just opened up with, that was like a pretty hard question, I thought, for like early in the test. That was like definitely a little bit cruel. But it's, I mean, hey, it's, you know, math, you got to be ready. So what is a solution to r of x equals 0? And here's a graph of the quadratic function r. So r of x equals 0 on a graph when the curve intersects the x-axis. Okay, so x-axis. So this one, honestly, all I'm looking for is where does the graph cross the x-axis? And this happens at -6 and at +14. Okay, so that's, if you know what to look for, this question is easy. But if you don't know what to look for, then yeah, you'll be there thinking for a while. So choice C is our answer here. Okay, cool. So moving on now to, that was question 3, going on to 4. So question 4, we have the function y equals 6 plus 6.25x. This function can be used to find the cost of joining an online music club and buying X songs from the website. Okay, so X is the number of songs from the website. Based on this information, which statement about the graph of this situation is true? So when you have y equals mx plus b word problems, m is the rate and B is the fixed amount. So when I am looking at this specific question here, so this is the fixed amount. The fixed amount is 6. So here, the function can be used to find the cost of joining an online music club. So this is like, I guess, the startup fee, and this is the cost per song. Okay, so this is like the cost of each song. All right, so then the y-intercept represents the cost of each song. That's wrong. That would be the slope. The slope represents the cost of each song because that's a rate. The y-intercept is the fixed amount. The cost of joining the music club. This one sounds good. Okay, but remember, a good strategy for multiple choice tests is not just to stop when you get to the right answer. Just if you have time, look at the wrong answers and see, are they for sure, like definitely still wrong? The slope of the graph represents the total number of songs bought by members of the club. That would be X, not the slope. They even said X when buying X songs from the website. And the slope of the graph represents the number of songs each member buys. No, the slope is the cost of each song. G is definitely our answer. Okay, this one here, we have a situation where we have figure 1 through figure 5, and we want to know if the pattern continues here, which expression can be used to find the number of circles that make up figure n. I mean, for this one, if you want to just use the calculator, what you could do is go to Stats, Edit, and you make a list here. So figure 1, 2, 3. So figure 1, 2, 3. And 3 points should do it, but to play it safe, we could use a fourth one. But just count. Figure 1 has 3. So we have 3 here. We have 3. Then we have 4, 5, 6, 7, 8. And then after this one, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so just record the figure number and the number of circles. And this is a quadratic relationship because all the answer choices are in the form of a quadratic. So here, I can just go to Stats, Calculate, and do a quadratic regression. Oh, hope you're good luck on your STAAR Algebra test. 8th grade too. Wow, so you're taking it advanced. That's really awesome. So I'm glad you're here. Hope you're having a good day. So if we look here, let's just use this data then. Okay, we can just write the quadratic regression. And now that'll just give us the answer all at once. So we have ax squared. A is 1, so we have 1x squared. And then we have plus 2 times x here. Let's just see. So this is b is equal to 2. So we have plus 2 times x. And then c is equal to 0. The only difference here is that they use n. So I'd say n squared plus 2n. So just using the calculator, and you're going to get choice A. If you really want to play it safe, though, what you could do is you say there's 3 here. Then there's 4, 5, 6, 7. And then after this one, let's just see. We had 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You could just plug in to see that this is checking out. So here, if we look, figure 1, we plug in 1 for n. We would have 1 squared plus 2 times 1. And this is going to give us 1 plus 2 is 3. If I plug in n equals 2, I should get 7. So if I do 2 squared plus, and then I have 2 times 2. So this one here, let's just see, is working out to, we just count 1, 2, 3, 4, 5, 6, 7. Oh, this is 8. Yeah, I thought something looked off here. So this one here had an 8. Okay, let me just double count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's odd, even, odd. All right, so it is alternating here. So when I do 2 squared plus 2 times 2, this is going to give us 8. See, that's why I hesitated a bit. I was like, wait a minute. Something seems up. Now when we plug in 3, it should give us 15. So I have 3 squared plus 2 times 3, and 9 plus 6 is equal to 15. Okay, if I had to keep going here, let's say I did 4 squared plus 2 times 4. I have 16 plus 8 is 24. And if I count here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so choice A is looking good. But remember, you can just do a quadratic regression right in the calculator. All right, so moving on to question 6. Alrighty, and thank you to anybody stopped by. I see we have 3 people here right now. Yeah, so feel free to say hello. Oh, at Drawlings. I don't know if I'm saying it right, or I'm sorry if I'm Dr. something maybe. I don't know how to pronounce, but hello anyway. I'm glad you made it. So yeah, I'll send some hearts in the chat. Thank you all for being here. I appreciate you all supporting. All right, and good luck this week. I'm from New York, and right now I'm on my spring break, so this was like the timing worked out really nice to be able to do these live streams. All right, cool. So question 6: one wall inside a shoe store is used to display very wordy questions. A lot of word problems. Not that word problems are bad, but you just got to like really have that mental energy to just read this all. So walking shoes and running shoes, and there are 135 pairs of shoes. All right, let's just see. So this one, where's the key phrase for us to highlight? Okay, so here, there's 2 types of shoes. There's walking shoes and running shoes. This is the total here. So the total is 135 pairs of shoes in the display. And now they tell us there's 1.5 times as many pair of walking shoes as there are running shoes. How many pairs of walking shoes and running shoes are there? So for this one, what I would say here is just define the walking shoes and the running. Okay, so here they're telling us there's 1.5 times as many pairs of walking shoes as there are running shoes. So if I call this X, I could call this one 1.5 times X because they said there's 1.5 times as many pairs of walking shoes as there are running shoes. And in total, there's 135. So we could do 1.5X and then plus X equals 135. Okay, and then from here, it's just a matter of combine like terms. There's an invisible 1 here in front of the X. So 1.5 plus 1 is 2.5. Times X equals 135. And now from here, just divide both sides by 2.5. All right, so here, we could just type this into a calculator. So looking here, I might as well just open one up just to model everything. So 135 divided by 2.5 works out to 54. So X is equal to 54, which tells us, if we look here, the number of running shoes is 54. And if we multiply 1.5 by 54, we would get the number of walking shoes. So I'll just move all this stuff over. But half of 54 is 27, and 54 plus 27 is 81. Okay, but we're going to get 1.5 times 54. And yeah, the math I'm doing in my head is I'm taking half of 54 is 27, and then when I add it to 54, I get 81. Okay, so there are 81 pairs of walking shoes and 54 pairs of running shoes. So choice J. Okay. You said, oh, I'm not ready for this. Well, the best you could do at Hope You're Having a Good Day is, I get this a lot. I've done a few live streams now, and I've been teaching a while. It's a normal feeling to say like, oh no, I'm not ready. But the best thing you could be doing is what you're doing right now. You're preparing, you're trying to learn some math. And that's really like the most you could hope for. So yeah, just do that. Oh, Xiaolong, hello. One of my old students. Welcome back. Nice to see. I'm glad that you're in the chat and saying hello. It's a pleasant surprise. So yeah, if anyone doesn't know, Xiaolong was one of my students last year, AP Calc BC, and he did very, very well that year. So I appreciate you being back. I hope you have that confidence now that you believe in yourself, because it's yes. Can you ask a question? Absolutely. So what's your question? So I'll hopefully be able to answer. So let's just see here. The mapping below represents y as a quadratic function of x. Which representation shows the same relationship between x and y? Okay, let's see. For this one, is there a nice way? Well, what we could do here is we could type these in and just do a quadratic regression. Yeah, Shalong, I'm so happy you stopped by. I'm not just saying it. Like that's one of the prizes of teaching for as long as I have. Like hearing from the previous generation of students, like your class of 2023 was a special group. You set the bar. You especially like set the bar very high for future generations. Like I meant it when I said it. Like how proud I was of your group. Like your group was just absolutely awesome, and I'm just trying to keep that momentum going like each school year to try to like, recreate it or, innovate and all that. But it means a lot like being able to teach and to have a group that's like really just focused and locked in. So for anybody watching, yeah, this particular group to say nice things, we would have visitors walk by the room and they would say, "Oh, I'm sorry, are they taking a test right now?" And like this group was just so concentrated that, they really just brought it. They were a special group. So what I'm doing here is I'm typing in the X's and the Y's in the L1, L2 column. And then I'm going to do stats, calculate quadratic regression. This is probably our best bet here in order to, do this question, just so we don't have to try to like do too much plugging in if it's not necessary. So now that we have this typed in, this tells us that our function y is equal to 0.25 or 1/4 times x squared. The b value is 0, which wipes out the middle term, and c is -4. So if we just look, see, this matches up with choice D. Okay. Otherwise, what you got to do is like just try to match things up. Like you say, all right, -2, -3. And you're like, oh, cool. Like this point matches. But then eventually they're not going to match. Like, let's see, where does this one? Oh, here it is. So -1 going to -3.75. Okay, like this is the -1 should be, yeah, -1 goes to -3.75. The vertex here should be at 0. So that means at +1, we should also have -3.75 here, which this one does give. So why is this one, where's the culprit here? Maybe -4, -6? Is that the one? That could be it. Let me try that. -4 squared times 1/4 -4. So 16 divided by 4. Oh, here it is. Okay, so that's 16 over 4 is 4, and 4 minus 4 is 0. So this one should have the point -4, 0. Okay, so that should be one of the roots here. Not, yeah, 0, -4 should not be. Although 0, -4, oh, I'm sorry, -4, -6. This is the point here that doesn't match. That's the one that eliminates. Because I'm just thinking out loud and seeing why do the points not work. Okay, and let's see. Yeah, the other ones here, like you could just graph this also and go to the table of values and show that it doesn't match up. Okay, but honestly, like this one here just works fine. Okay. Can we use a calculator for the last one? I mean, yeah, you could use a calculator for a lot of these. So, yeah. All right, let's just see. Oh, wait, can we use a calculator? Yeah, so which one did I? Yeah, this one here. All right, so how do I do this with a calculator? And just take your time to figure out how to do this without one. But it's all right if you just like, hey, like I want to get this right. So ready? I want to solve this, and I don't feel like doing the math. Math up numeric solver. 1.5x plus x. This works for linear equations, okay? Don't do this for quadratic. This works for linear. So enter, okay, and then solve. X is 54. All right, so. Oh, you live in Texas too? Yeah, no, I'm trying to build up my number of subscribers from Texas because I know it's like, landmass wise next to Alaska. Although I should stay in my lane. I'm only a math teacher. I don't want to say like something out of place, but I believe, yeah, Texas in terms of landmass is the second biggest, but pretty like massive population in Texas. So I was like, hey, this is, and they have like all the state exams like just available online. So I was like, oh, cool. Like this might be a good idea to start reviewing for that test. And plenty of resources. Okay, so the slope of the line that passes through this point and this point is 1/8. So what is the value of W? So for this one, you got to know the slope formula, which is probably on that reference page. So this one here. Okay, so there is your formula. And this is like your x1, y1. This is your first point. And this is your second point. The only challenge here is that they told you the slope. So they basically told you that m is 1 over 8 equals y2 is 4 minus y1 is w over x2 is negative 10 minus x1 is negative 6. So if we had to, let me see. I think that calculator would also do this algebra for us if we went back. So let me just see. Math, numeric solver. So if I had to here, I'm going to clear this out. I could say 1/8. But now I'll show you another trick. Alpha, y equals, enter. Pulls up a blank fraction. 4 minus, let me see if I can write w. Alpha, subtraction sign puts a w. Will they let me write it in terms of w? If they don't, I'll just switch it back to x. Negative 10 minus negative 6. So I'm just going to say here. So w equals 4.5, which is the same thing as 9 over 2. And this one, just double checking, should be choice H. It is choice H. All right. So if you don't feel like doing any algebra, just type that in, okay? But it is an algebra test, so I am going to show how to do it that way also. All right, but if you just want calculator magic, then calculator magic. Okay, actually, got to be able to circle this. All right, so the long way. So for this, first I would simplify. I would say 1 over 8 equals 4 minus w over, this becomes negative 10 plus 6, because I have minus minus. And then negative 10 plus 6 is negative 4. And then I cross multiply. I have 8 times 4 is 32. Minus 8 times w is 8w. I have to make sure I distribute. So just pretend there's parentheses here, or actually write them in. So equals negative 4. And then plus 4 plus 4. Okay, so we have plus 4 on both sides. It's going to give us 0. And then from here, there's a few ways you could do it, but I could just say here, like, just add 8w to both sides. Okay, so 36 equals 8w. And now just divide both sides by 8. Okay, so if you want to do this by hand, you get here. So w equals 36 over 8. And now to reduce, divide the top and bottom by 4. And you're going to get 9 over 2. So see, 9 over 2, either way. All right, so moving on to, this test is long, so I'm going to definitely just keep moving here. All right, so the population of Webb County, Texas from 2000 to 2010 is shown in the graph. The x-axis is the number of years since 2000. If this trend continues, or if the trend shown in the graph continues, what will be the population of Webb County in 2015? So number of years since 2000, 2015 would correspond to x equals 15. Because if I did 15 years since the year 2000 is 2015. Okay, so they gave us like a little riddle to solve here. Now, if you don't feel like doing this by hand, so calculator magic. Okay, so calculator, let's see. We go to stats, edit, I clear out the table. Okay, I clear out the table here and here. And I'm going to write in 0, 193. But they told us there's a linear relationship here. Or, yeah, they're suggesting that there's a linear relationship. So I'm just going to type in 0, 193, and then 10, 250. And now stats, calculate linear regression is option 4. So if you don't want to write the equation of the line yourself, then you could just use the calculator to do this. And now I'm going to go over to the y equals and borrow that information. So we have 5.7 times x plus 193. Now, what's going to happen here is I'm going to press graph, and I'm going to be like, oh no, I can't see anything. You know, this isn't fair. The reason being the x-axis goes up to 10. So my window, my x minimum, I'll switch to 0. but I'm going to leave my x maximum at 10. Actually, no, I lied. Sorry about that. X equals 15 is what we want to see. So maybe I'll go out to x equals 20. And then I look at the y-axis here is going up to 300. But some of these answer choices go up to 471. So maybe I'll bump the y-axis up to 500. Now I press graph. And there we can see what's going on. So what's going on at x equals 15, I just press second graph and scroll to 15. And there it is. Okay, this is what we want. Okay, so this is going to help us now answer the question. So all of this, all right, you could just do right in the calculator. So what is the population? We're going to say 278.5, but then you're like, oh no, my answer is not there, but they told us this is the population in thousands. So I go times 1,000, and the calculator will do this for us, or just move the decimal 3 spaces to the right, and you're going to get 278,500. Okay, so choice B. All right. So moving on here. All right, let's just see. Oh, you want to donate? Oh, I appreciate that. You don't have PayPal. Do you have Cash App? I got to figure out how to get that all set up. What is the super thanks button? Not to say, oh, super thanks, but I guess if that's not accessible, like you have to use PayPal to use super thanks. I guess I've never, I guess guilty. I haven't used super thanks. I just try to tip myself right now, but that would just be silly, right? If I tip myself, but I appreciate that. Thank you. You all being here, honestly, is just it means a lot. You know, having people to support the stream. But let me see. Cash App. I got to look that up. That's something you know what? It's just making me wiser. So Cash App, YouTube channel. Maybe there's a. Yeah, I'd have to do some homework on like syncing it to. I don't have Cash App though right now. But I appreciate that. You know, just the acknowledgement. No, you know what? Just my reward is like you. If you're broke, just study for your test. You know, like that. That makes me happy. I do appreciate it. But yeah, I would. I just like I appreciate the gesture, but it's I could link it in my bio. All right, yeah. See, these are the things I'm sort of kind of new to streaming. I've been doing YouTube a while, but that's you know what? I'm gonna write that down for notes. Look up Cash App, link in bio. Cash App. Look up how to link in bio. Oh, so what is it? PayPal has a monopoly on super thanks. Is that how? Yeah, I guess I should learn more about the ins and outs of YouTube, like the behind the scenes business side of things. It's pretty interesting though, like the infrastructure of it. So let's see. 10. We have a city employee paints curbs in parking lots and replaces road signs. All right, so let's see. So a lot of info here. A lot of, like I said, very wordy questions. So you, the theme here, take your time reading these and just really try to understand what's going on. So it takes 0.5 hours to paint a parking lot curb and 2.5 hours to replace a road sign. The function below can be used to find C. So this is an important detail here. C is the number of parking lot curbs the employee paints when he replaces. R is the number of road signs in a 40-hour work week. So here we go. Supporting detail here. If the employee painted 20 curbs in 1 week. Now remember, they told us C is the number of parking lot curbs. So C is here. If the employee painted 20 curbs in 1 week, how many road signs did he replace that week? So really all they're saying here is they're like, hey, C is equal to 20 and plug in and solve for R. Okay, the trap in this question would be to plug in 20 on for the R value and then simplify. But yeah, here you want to do this. And look, if you're like, oh, I don't want to do algebra, like that's too much, then just that same trick, math up, numeric solver, 20 on this side. This one maybe like, this is like such a cool trick to have. It's like, really does just give you like superpower. You could put X instead of R, it doesn't matter. I could just type X faster, then I could do alpha and then the times button here. So this, and then graph X equals 12. So choice J. Okay. So this will, yeah, the calculator does all the magic for us. But if we want to showcase our skills, call this 20 over 1. And now just do some algebra here. So 20 times 0.5 is the same thing as saying half of 20 is 10. When I multiply by 1, it doesn't change the value of 40 minus 2.r. I'm sorry, 40 minus 2.5r. And then from here, you could go minus 40 on both sides. So algebra should get us the same answer. Now we have negative 30 equals negative 2.5 times r. Divide both sides by negative 2.5r. And a little trick here. I mean, whatever. This you can just type in a calculator. I guess we don't need to show the trick. Oh, my bad. I shouldn't have wrote the r. Sorry about that. That would be silly to do that. Okay, so just dividing by negative 2.5. This cancels out. And we have r equals. And then a negative over a negative is positive. And then 30 divided by 2.5 is 12. Okay, so same answer. Cool. Oh, we have another here. Let's see. So at Danny, yeah, I miss. It's like I said, it's so nice when we have the old people come back to say hello. So, Danny, yeah, thank you for stopping by. It's been cool, like being at the same school now for 11 years and just having like, I think the other year I had like people even from like 2018, class of 2018, coming back to say hi. That's like it's just not. I'm always happy to hear from all of you, and I just hope you're all doing well out there. Let's see. All right, so going on here, and we have a customer at a bank. Oh, customers at a bank are charged a fee when they exchange U.S. for foreign currency, and here's the function. All right, I mean, it's not good to go too fast during these questions, but I kind of just scanned for the important stuff. So this function can be used to determine the number of Japanese yen a customer receives in exchange for X dollars, where X is greater than 5. Which table shows this relationship? All right, this one is also just, oh, wow, a student got a 100. So my algebra told last year, one student got a 100 on the STAAR. Yeah, I mean, look, it's possible. It takes a lot of commitment to get to that level for sure. The students that I've known that have gotten the 100, they like almost all say they just went through a ton of questions. But it's also like that day, like I call it like the rule of 5, or I mean, I've heard it called the rule of 5. I shouldn't say I invented it, but the idea being that like on a 5-day work week, one day you're going to be awesome, one day you're going to be lousy, and then the other 3 are just business as usual. So if you show up on your sharpest day and you're prepared, then that's awesome. Rally sound, like an amazing. Yeah, I do need a rally sound. That's cool, like a horn or something, like the. That would be cool. Like I don't know. I think of almost like assembling like the Avengers or something in that regard. Like when I have to call back my old people. I just hope they're all doing well out there. If they stop by to say hi, then cool. It's all right. I just want to meet approaches. Like just keep working at it, and we'll, little by little, we'll get you there. I'm rooting for you. All right. So here I'm gonna press second window, and I'm gonna switch from auto to ask. The independent variable goes from auto to ask. And now watch this. I go to the table, second graph, and it's blank. So 50, 85, 120, 200. I could just start typing in custom values now. 50 should give me 3,532 points. So you see, C is already looking good. A is no good. This one doesn't have 50, so that's sad. What if I type in 10? See, this one's no good either, because 10 should give us 392.5, not 3140. And then if I type in 65, let's see, is this one any good? It's no good. So choice C is already it. But watch what happens if I type in the remaining one. So I have 85, I have 120, I have 200. And it gives me everything. You might say, wait a minute, that one doesn't match. But if I scroll up to it, you see it does match. Okay, so this one here is good. Okay, this one is in fact just, is good. So here we're going to have choice C. All right. Cool. Question 12. All right, only, yeah, these questions can take a little bit of time. This one's a nicer, like a little break though. Not as wordy, it's a little bit more straightforward. Unless you don't like geometry, then sorry. All right, so rectangular prism, just think of like a box. And they told us that the, let's see, the width, length, and height. So I like to say volume is length times width times height. Let me make that neater. So length times width times height. So here we'll say the length is x squared y. The width is just x. And the height is y squared. So the volume, we just multiply these three. Oh, you don't like this? I'm sorry. Yeah, I guess there's like no way around it. I mean, you could plug in random values for x and y and just then plug into the answer choices. That works. I'll show you a trick. So x squared y, the width is x and the height is y squared. And now when I multiply, order doesn't matter. So I'm going to multiply x squared and x. And then I'm going to multiply y and y squared. And now let's see what happens. We have x times x squared times x to the first. Law of exponents here. A to the b times a to the c is a to the b plus c. When you multiply exponents that have the same base, you add the exponents together. So here I would have x to the 2 plus 1. And the invisible power here is y to the first. So I'd have y to the 1 times y to the 2 is y to the 1 plus 2. So this simplifies to x to the third and y to the third. Okay, so 12 is J. All right, so let's see. If you want a trick to try out, so we have x and we have y, is, you know what, you could just pick out random values here. So let's say x, like I pick out x equals, I don't know, 3. I'm going to press store as x. And now every time I write x, see, I get 3. And now y is alpha y. So maybe I'll pick out y is equal to 7. So I press 7, enter, and then I press store as alpha y. Okay, so there's this. So now watch what happens. I'm going to do x squared times y times x and then times y squared. So I could just pick random values here since it's multiple choice. And then I have to go searching through all the answers here. So I get this big number. But then I do x to the third. So x up arrow 3. And then y is this one. Let's hope it works. Yay, same answer. Okay, so you go that route. And that's fine. If you write in the wrong answer, like x squared, y squared. So I do this. Then they don't match. You're like, oh no, that's not the answer. All right, so 12 is J. All right, so here, all right, this one's more conceptual. Oh, in 5th grade, and this hurts your brain. All right, well, you know what? It's, what's it called? I guess it's good for you to just kind of see it, like kind of like you're listening to music. Like, don't place too high expectations for yourself, because you're skipping a few grade levels here if you're in grade 5. So, you know, good luck with your 5th grade exams. I don't know. Are you, so at my 5th grade friend here, are you doing the STAAR 5th grade exam? Is that what you're swinging by for? You just heard like STAAR math review, or oh, just wanted to see. Cool. All right, so let's see. This is line, which line is this? The graph of line T. So here's line T. And they told us line W is steeper. Okay, this means like in real world language, like you would slide down faster. So think if it was like a slide or a roller coaster, like you would go faster. So that just means like it drops at a faster rate. Like, so maybe something like this. Okay, like that's what I'm just imagining. Steeper means like this one I would slide down maybe kind of fast. This one would be like, whoa, really fast. So line W is steeper. which means it could be looking like this, and the y-intercept is below the y-intercept of line t. Okay, so it has a y-intercept that is below the y-intercept of line t. So the y-intercept of line t, see here, like if I write t in red, the y-intercept of the red line is over here at 2. Okay, so just be mindful of that. All right, now looking at the answer choices, which function could be represented by line w? So we're saying this one here in purple is line w. Well, one thing to pay attention to is the slope of the red line. So slope, you could just look for the rise over the run. So rise over run. And if I look here, see my rise over run, the line is dropping down. So I'm going down 1. So I'm going to write negative 1. And then I run to the right 2. So my slope is negative half. I always like to bring up slope guy also. If slope guy gives somebody a nightmare here, I'm sorry about that. But when you have a negative slope, your line is decreasing. It's dropping. Okay, so that's how I know we're going to have a negative slope for the red line. And if this one's, all the answer choices are negative here, we have like a steep negative sloping line. So here, what it helps to know is that when your line has a steeper slope, if it's negative, it means it's like becoming more negative. So I'm thinking our slope here is going to be less than negative half. That's going to make it steeper. The closer your slope is to 0, the more horizontal it is. Okay, a 0 slope is horizontal. So as I move away from 0, so I'm to the left of 0, I go more to the left of negative half. That's going to make the line steeper. So just using that thought experiment, that's leading us towards the potential answers here. So we look, the y-intercept is 2, and we want our y-intercept of the purple line to be below that. So we need our y-intercept, our b value, to be less than 2. So if you think of y equals mx plus b, the b value has to be less than 2. These b values you see here are greater than 2. A y-intercept of 4 would be above. So these answer choices are out. So now it's down to these two. But negative 1/4, if you think about the number line. So I'm going to show you with the calculator also how to do this. But if I look at negative half, negative 1/4 is between 0 and negative half. So this is closer to 0. So this slope would be less steep. Okay, so this would be less steep, not steeper. So this one's out. It's got to be A. All right, but you do get a calculator. So for this one, what I would do is type in the equation of the line. We have a slope of negative half. So alpha y equals enter. Negative 1/2 x was the slope. Or negative half was the slope. X, and then the y-intercept was 2. So that's the first line. And then if we look at choice 1, see we get negative 2/3 times x, and then minus 1. And if I do this, zoom 6 puts the graph back to normal. So zoom 6. This one is definitely steeper, and the y-intercept is lower. Okay, if I were to graph the one that we crossed out here, something like choice D, negative 1/4 x minus 1, watch what happens. So negative 1/4, I'll do this in pink. So negative 1/4 x, and then minus 1 is going to be less steep. See, this one is less steep. You would not slide down this one as fast as the one in blue. All right. So A is our answer. That one was like kind of tedious to get through, but we got through it. All right. So here we have a senior employee and a junior employee. So organizing your work helps for questions like this. So senior and junior. Okay, so we have a junior employee and a senior employee. And they tell us that the senior employee works 16 hours. Okay, so far I have 16 hours and earns $39.50 more than the junior employee who works 18 hours. So this person works 18 hours. The senior employee earns $14 per hour. So let's think about this. If they earn $14 per hour, so this is like their rate, and this is the like hours worked. So if we multiply their hourly rate by the number of hours worked, this tells us how much money they made. So here, for the junior employee, they work 18 hours. Because our goal, let's first think about our goal. We want to know what is the hourly pay in dollars and cents for the junior employee. So let's say they make X dollars and cents per hour. So 18X, but this is the supporting detail here, that the senior employee earns $39.50 more than the junior employee. So here, I can't just say these two are equal unless I balance things out. Right now, the senior makes more money. They make $39.50 more. So if we help the junior out, let's say I go, all right, I'm just going to give you $39.50. Now they would make the same amount. So then I could say they're equal. Okay, and then from here, I just work this out. All right, I would do this like right here. So let's see, 16 times 14 is 224. So I have 18x plus 39.50 equals 224. And sorry about this sloppy zero here. So now to solve for x, I could just use that equation solver, but I already showed how to use it a few times. So I'll just now get to doing this, the more traditional way. So 224, I would subtract this and then divide by 18. I'm just doing this so that I don't have to keep switching back and forth. And then I'll explain, where this is all coming from. Okay. So here, now we work this out. I go minus 39.50 on both sides. And I don't know what just happened there. Minus 39.50. All right. Oh, and the chat is, I'm sorry, the stream is growing. We got more people. So thank you all for stopping by. And one thing I would appreciate is if you have not subscribed, but you find this stream to be helpful, please subscribe. And I mainly teach AP Calculus, BC. So I will be doing a live stream for the AP exams. So if you do wind up in one of those AP classes, I could be, your YouTube teacher to help you through the exams. I'm happy to do that. I'm trying to branch out to all the grade levels. Okay, so this, when we subtract and now just divide both sides by 18, and that's what I did in the calculator over here. I divided by 18. So x equals 10.25. So the junior employee makes $10.25 per hour. All right, this test, though, I printed in 2015. I'm sure they got a raise by then. All right, cool. Oh, let's see. Can't wait for high school. Oh, good for you. Yeah, I mean, don't wish your years away, though. Just enjoy your youth. So, all right, let's see. All right, so I meant to be an 8th, got promoted. Your teacher is so strict. Yeah, well, you know what? Yeah, strict is, I don't know. I was actually thinking about putting out a vote or poll to see what kind of teacher people prefer the most, like the strict teacher. I don't want to say laid back, but I have to organize it too, though, first to see like which personality of teacher do you mix the best with? Because some people say, oh, strict is makes it kind of tense, but some students say they like the strict teachers because it keeps the room in order. So that's one of the hardest decisions you have to make as a teacher is to know all right, what game am I playing this year? Am I going to be the strict one? Am I going to be more laid back? Because you can't be too laid back because then you lose their respect. It's it's tough. Okay, so let's see. So 15, we have 3 different workouts. A runner burned 300 calories in 30 minutes, 350 calories in 35, and this many and this many. Based on the data, which statement is true if the number of calories burned is a function of the number of minutes? Okay, so here's the actual question. Which statement is true if the number of calories burned is a function of the number of minutes worked out? So when I look at this question, my thinking automatically goes to all right, workout 1, 300 calories and 30 minutes. If you divide 300 by 30, you just cross off common zeros, do 30 over 3 is 10. This tells us the runner burns 10 calories per minute. Okay, but then I just check the others. 350 calories in 35 minutes would be 10 calories per minute. And if you do it for the last one as well, you could see here that this is going to be a linear function. Okay, 200 calories. I mean, whatever, I'll just write it out. We're already committed at this point. In 20 minutes is 10 calories per minute. Okay, so the rate of change here looks constant. So what I'm just imagining here is like, yeah, every minute that the runner goes, they're burning 10 calories. So then which statement is true if the number of calories burned is a function of the number of minutes the runner worked out? So just think about this very logically. The more this runner runs, the more calories they burn, and they're burning 10 calories for every minute they run. So let's think, which statement is true? The number of minutes the runner worked out is a dependent quantity. No, it's not like you burn calories and then it's like, all right, I just burned 300 calories. Now, like, I have to do 30 minutes of exercise. Like, no, the number of calories burned depends on the number of minutes you run. Okay, if you think about what they said here in the question, think about this carefully. Let's say y equals function of x. So what they're saying here, that the runner burns 300 calories in 30 minutes. And they're saying here, the number of calories burned is a function of the number of minutes. When you hear y equals f of x, that means y is a function of x. So minutes would go here, and the calories burned would be the y value. And the y value is the dependent variable. Y depends on x. X is independent, okay? Independent in the sense that, like, if you're the runner, you get to decide how many minutes you're going to run, okay? And then the calories that you burn is a result of how many minutes you chose to run. Okay, so the number of minutes is dependent? No. The number of minutes is independent. The number of workouts the runner completed is the dependent? No, the function is minutes, calories, okay, not workouts. The number of calories burned is a dependent quantity. That is the one. Okay, that is our y value. That is the dependent one. Okay, the number of calories burned is a dependent quantity. The number of calories burned depends on how many minutes the runner runs. So if you say that a few times, you'll be convinced C is it. But now, why is D no good? The number of steps the runner takes is the dependent quantity. No, that's not it. We're talking about minutes and calories, not steps. So C is it. Cool. All right. Let's see here. So what is the range of the function shown on the grid? The range is the possible y values. And for this one, what I like to think of is like the high and the low, the high and the low. So the high point is here, and the y value at the high point is 4. The low point is here at -3. So then the range is going to be the set of all the possible y values. The y values here go from -3 to +4. To use this compound inequality formation here, we could just say -3 is less than or equal to y is less than or equal to 4. In words, this means y is between -3 and 4. Okay, that's what it means. Like, this is like this symbol here. This is like what it says in words. Y is between -3 and 4. So we look for the high and the low point. Okay, so the high point is at 4. The low point is here. So this one here is going to match up with choice G. Oh, yeah, ask questions. Go ahead. Type them in the chat. So my second oldest is in college, and he wishes he was still in high school. Yeah, I mean, just every stage is special in its own way, I would say. So, yeah, just enjoy the ride, Like, it's more about the grind. Like, this test is just going to be like a few-hour block of your life. So just make sure you're showing up each day and putting in the work, Okay. No, this chat, I got to say, I commend you all in terms of like community guidelines. This chat is like very nice right now. So I appreciate you all for being nice and respectful of each other. In the past, I had to appoint moderators if people weren't being as nice, but this group is especially nice. So yeah, ask questions. I do have 2 monitors set up, so I'm able to like kind of look left and right and see what's going on. But if you got questions, send them there, and I will, try to get to what I can. So all right, let's see. We're on 17, and we are 1 hour in. Okay, so I have a feeling this is gonna go to like 3 hours. So 17. These 2 points are on the graphs of quadratic functions f and g, and the graph of f opens downward, and the graph of g opens upward. All right. So which of these statements is true? So draw it out. Okay, draw it out. Okay, do not try to juggle all of this in your head. Okay, so we have this here. Let's take a look. So we have 1, 2, 3, and then up 2. And then we have 4, 5, 6, 7, up 2. So what they're telling us here, if I plot these points, so 3, 2 is here, 7, 2 is here. And notice that the y values match. So y equals 2 shows up twice. That's very important. So I'll color code this. I'll say f is going to be in blue, and the graph of f opens downward. So when I draw the quadratic f, let me just draw this as nice as I can. It's going to look like this. Okay, so there's the graph of f. The graph of g is going to open upward. So it's going to look something like this. And now we answer the questions. So let's think about Roman numeral 1. The graphs of f and g have the same axis of symmetry. That one is true. See, this line will cut both of those parabolas in half. So 1 is good. The graphs of f and g have the same x-intercepts. No, they don't. You can see the blue one crosses here. The purple one, the way I drew it, doesn't cross at all. So yeah, this one, not necessarily true. So it's either a 1 only or a 1 and 3 at this point. So it can't be 2 only because 1 is true. It can't be 2 and 4 because 1 is true. So now we just have to see if 3 is true. The graph of f, so f is the one in blue. The graph of f has a maximum point, which is true. See the one in blue? This is the high point. When it's a downward parabola that's opening this way, it's going to have a high point, and the one in purple is going to have a low point. Okay, so this one is good. So 17 is going to be 1 and 3. All right, so draw it out. Hard question. So let's see. Bit of off-topic question, but do you recommend band in middle school? Yeah, I would say so. I've read a bunch of books like on kind of like those like I don't call them, I guess like self-help books or advice for success. And one of the cool bits of advice that I got is like having a creative outlet. Not saying that music is not like its own path. I mean, you could spend your whole life studying music. It's wonderful. But it just like exercises your creativity for sure. And I think the more of those kind of outlets that you have, the more relaxed you are in your approach to school. Like being well-rounded. Some people would say like, oh no, being well-rounded is bad because then you're not going to be anything that great. But I would say no, like having something like band, if you're passionate about music, like for sure, like take it up. Because that's just something that's going to age as you age. Like you'll be like, hey, I'm getting better at music. And then it's just like more satisfying to play. And I do teach high school. I teach 10th and 12th grade. I teach geometry and I teach AP Calculus BC. So I haven't taught algebra in a long time. But I mean, in calculus, you use algebra all the time. So that's why I'm like, sure, I'll do all these live streams and help people out. And now I'm going back to make like 3rd, 4th grade math videos because I want to be like the people's online teacher for like a bulk of their school career. All right, so let's see. 18, we have a scientist is printing a research report on her computer's printer. If she prints in, let's see, if she prints in black ink only, B of T. All right, at least they used alliteration here, B of T for black ink. And then if she prints in color ink, this is the function. And the functions here describe the number of pages left to print after t minutes. That's why it makes sense that they're decreasing. Okay, wait, from your perspective, it would look like this or this. So they're dropping because as time goes on, the job is like nearing completion. So based on this information, which statement is true? Well, the slope in mx plus b word problems is the rate of change. Okay, so this is the rate. So for b of t, the slope is minus 33. And for c of t, the slope is minus 30. So if you think about this as a concept, this is t minutes goes by. Okay, so t is minutes. And b of t and c of t represents the number of pages left to print. Okay, so basically here, every minute that goes by, like 33 pages are printed, 30 pages are printed. So b of t, this is basically saying 33 pages are printed for each minute. Okay, each minute. And for the color printer, it's going to be 30 pages. So I'll just say like the same thing, pages printed each minute. So now we're ready to answer the question. So 18, the printer prints 3 more pages per minute in colored ink than in black ink. No, the black ink cartridge is faster, I guess, because it doesn't have to work as much because it's just sending out like one color. Like the color ink, it's got to have like red, blue, orange, all that stuff. So it's like more complicated what's going on there. The printer prints 3 fewer pages per minute in colored ink than black ink. That is the one. Okay. In color ink, we get 30 pages printed per minute. In black ink, we get 33 pages printed per minute. But now let's go through the others. The printer prints the same amount of pages per minute in either type of ink. Nope. The black ink cartridge goes faster, and the printer prints the entire research report in 152 minutes. Well, that here wouldn't work. If you set this equal to 0, 33 times 152 is way more than this. And same thing with this one. So like J is out. That's not it. You could find the roots, set it equal to 0 and solve, but I promise it's going to be way less than this. Just imagine though, like your report is 152 pages long and it takes you like 2.5 hours. Like that just seems silly. I don't know. Yeah, about 2.5 hours. All right, this one here, some algebra to shake things up. What we could do is type in the question and all the answers. So for something like 19, if you really wanted to, you're like, I don't want to do the algebra. That's too much work. Then sure, you're able to do this. Like if you just want to pass the test, I think I saw that in the chat earlier, like, hey, just get me through the test. Alpha y equals enter. I could just type in the question. And so here's this part, and then plus 3 parentheses, and we have 5/3, and then times x minus 2. All right, I'm going to use x instead of m. And now, spoiler, choice C is the answer. So I'm going to write 3x squared plus 7x minus 6. Now I'm going to press zoom 6. See, same graph. If I press second graph and go to the table, I'm going to press second window and switch independent back to auto. You see, I get all the same matching values here. So C is definitely it. Okay, just calculator magic alone. So, all right, let's see. So now the algebra way. So we have 2m. Oh, which high school do I teach at? I teach at a high school named Newdorp High School in Staten Island. So that is where I teach. I've been there for 11 years now. So teaching for quite a while. So I'm doing 2m times the first term plus 2m times 1. And then I have plus, I'm going to distribute the 3 now. I have 3 times 5/3 m. And then I have 3 times negative 2 is minus 6. So let's see. 2 over 2 cancels. I have 3 times m is 3m squared. So you see this term matches. And now I have plus 2m times 1 is 2m. 3 over 3 cancels, so I have plus 5m. Then I have minus 6. And notice these are like terms. So I have 2m squared plus, and if I do 2m plus 5m, I'm just going to add the numbers in front, the coefficients. 2 plus 5 is 7. So I get this, choice C. Cool. All right. Based on the graph, so we have this line y equals mx plus b, whatever. What is the value of x when y is negative 7? So go down to y is negative 7. So y is negative 7 is here. And then you want to follow this to the line. Ready? So we're going to go y equals negative 7. We follow to here. Okay. And now we scan and we're like, oh, all right, this is the point, negative 5, comma, negative 7. So we're saying when is the y value negative 7 at x equals negative 5? Okay. So what is the value of x when y is negative 7? The x there is negative 5. So it was a little tricky, I guess, because you have to search in terms of x, but that is the way. All right. So moving on here, we have a contractor painting a square surface. So here's our square surface. And they're painting it, so we're talking about area. So he needs to know the area of the surface in order to buy the correct amount of paint. Since the contractor always adds 25 square feet to the area, he buys extra paint. Which function can be used to find the total area in square feet A of x the contractor will use to determine how much paint he needs to buy? All right, well, the area of a square, you could think length times width, but the length and width are the same. So here I could just say the area of a square is x times x, or x squared. So our area function is going to start off as x squared, but then you're like, oh no, my answer is not there. Because they said the contractor, here's the detail right here, always adds 25 square feet to the area. So here's the area, and let's add 25 square feet to it, and this matches up with choice D. Okay, this would be if the contractor buys 25 times the area. That's crazy. That's way too much paint. This would be if the contractor added 25 to each side of the square and then found that area. So this isn't it. And then this one's the most dramatic. He multiplies each side by 25 and then finds the area. Then it's like doing 625 times the paint he would need. So that's like really excessive. All right. So moving on. Question 22. We have the graph below, shows this change in the value of a car over several years. So yeah, you buy a car, which probably doesn't apply to anybody here. Probably didn't buy a car yet if you're in algebra. If you did, then awesome. Like, tell your story one day about being a prodigy. But you buy the car, and the moment you drive it away, it loses value. Okay, it loses value like usually the quickest in the beginning, and then it starts to stagnate over time. And I guess it eventually plateaus because then you just sell it for scrap metal. So that's what this is telling. So the car lost about 1/2 of its value every 3 years. Well, that's not the case because, like, yeah, in the beginning, you're like, all right, $12,000. And then 3 years goes by and you're like, ooh, $6,000. Like, that's half. And then another 3 years goes by and you're like, 6,000. Oh, wait, 4,000. But 4,000 is not half of 6. So this one's already not looking good. But then especially as you get out here, you see as 3 years goes by, we're like 3,500 and then like 3,200. That's definitely not half. Okay. So, all right. Moving on to choice G. The car lost about 1/4 of its value every year. That one, no, same idea. From here to here, it's not losing 1/4. So that answer choice is out. The car lost less of its value between 9 and 10 than between, yes, this one is true. So if we look here, between 1 and 2. So at 1, we're over here at like, let's say like, I don't know, let's say like if this is 9,000 and this is 8,000, let's say this is like $8,500. And then here it's, I don't know what just happened, 8,500. And then at 2, we're at $7,000. So from year 1 to year 2, the price went down 1,500. Okay, so it went minus 1,500. Like, oh no, that's so much. From 9 to 10, though, you see like we're at like, let's say 3,500. And then year 10, like maybe we're at 3,200. So this is like a drop of $300, went minus 300, which is it lost less of its value. So the car lost less of its value between years 9 and 10 than between years 1 and 2, definitely. And this says the opposite, which is not true. Okay, so H for 22. All right, moving on. Question 23. All right, so we're closing in on the halfway point. I think 27 is the halfway point. What is the equation in standard form of the line that passes through this point and has this slope? So let's see, y minus y1 equals m times x minus x1. So that is our point slope form equation. So this is the point x1, y1, and this is the slope m. So we just plug in y minus -8 equals the slope times x minus x1. Now minus minus changes to plus. So we get here, and I have 1/4 times x is 1/4 x. When I do 1/4 times -4, I get -1. And I'll just show that over here. 1/4 times -4. 4 over 4 cancels, and this is like 1 times -1, which is -1. So that's where that's coming from. And now here, they write it in standard form, which is going to get rid of all the fractions here. And the way they get rid of the fractions, let me think of the nicest way to do this first. I guess I could just solve for y first. So maybe I'll just do that. -8. We could do that first. And now we have y equals, and we've got 1/4 x. -1 minus 8 is -9. So we get here and we're like, oh no, my answer is not there because this is slope-intercept form, not standard form. So then to get it to match the answers, I'm going to go times 4. And let's see where this sends us. 4 times y is 4y. So I get 4y equals. And if I do 4 times 1/4, so sorry, just all of a sudden I have an itchy eye. All right, so 4 times 1/4 x is 1x, because 4 times a fourth is equal to 1. And then I have 4 times -9 is -36. So then from here, notice it's, I would have 4y minus x, which isn't going to match. They all start off x minus 4y. So if I want to make this say x minus 4y, I would go plus 36 on both sides. And now I have 4y plus 36 equals x, and then I go minus 4y. Yeah, right now my marker is like possessed or something. I don't know why it's doing this. Okay, so 36 equals x minus 4y. All right, cool. All right, so moving on. So choice A. All right, so word problem here. So we have a spiral notebook, and it contains 30 more sheets of paper than a new memo book. So we have spiral and memo. So you see, so yeah, S is for spiral, and M is for the memo book. So at least they did that for us. That was nice. So the letters match. So a spiral notebook contains 30 more sheets of paper than a new memo book. So I just think about this again. If the spiral notebook has more sheets, then that means S, and I'll just write this maybe in a completely different color. So we're going to have S is equal to M plus 30. Okay, and think about this very carefully. The spiral notebook S contains 30 more sheets of paper than the memo book. So if I take the memo book and add 30 pages, now it has the same number of pages as the spiral. Okay, and the total number of sheets of paper in, okay, so 3 spiral notebooks is 3S, and 5 memo is 5 times M, and the total number of pages in both is 810. So this is looking like F. All I have to do is just go take this and go minus M on both sides. Okay, so this cancels. S minus M equals 30. So here's equation 1, and here is equation 2. So F. All right. So let's see. All right, just checking the... Oh, the chat's been going here. Why did it go? The live stream went mute, or... All right, so... All right, I'm going to move on. So, yeah, if anyone else wants to confirm that also, then cool. But we will continue here. And wow, 77 people stopped by for the live stream. So thank you. I appreciate the support to all of you. So this one here, I could just type in this and the answers, but I'll show the AC method. So AC equals, and we have A is here, B is here, and C is here. So I'm going to just work out A times C is going to be 6 times 5. And this is going to be equal to 30. And then our B value here is negative 13. Okay, so let me just see something real fast. All right, so moving on here. We are going to use the AC method. So we need two numbers that have a product of 30 and a sum of negative 13. And the two numbers are going to be negative 10 and negative 3. Okay, and now watch what happens. If I break this up, 6x squared minus 10x minus 3x plus 5. That's how I'm using these two numbers. I'm breaking up the middle here into two pieces. And if I do negative 10x minus 3x, I'm going to get negative 13x. So now I could factor by grouping. So greatest common factor here, I'm going to have 2x, and I'm taking out 3x minus 5. And now I'm going to take out a minus 1, and I'll have 3x minus 5. Okay, so I'm just factoring out a factor of negative 1. I do this because I need these to match. All right, and now from here, I could take out the 3x minus 5. And from the first term here, I'm left with 2x. And the second part here, I'm left with minus 1. Okay, so 3x minus 5 times 2x minus 1, 25 is B. All righty, cool. All right, so going on here, we have the average blue whale gains weight at a constant rate each day during its first 6 months of life. The relationship between the average blue whale's weight in tons, W, and its age can be modeled by this linear function here. And based on this relationship, which statement is not true for the average blue whale? Okay, so the average blue whale weighs 3 tons at birth. So birth would be at D equals 0. At D equals 0, W would just be equal to 3. See, this would just cancel out and give us 3. So which statement is not true, not which one is true? So this one is true, so it's out. When the average blue whale is 5 days old, it weighs 20 tons. So if D is equal to 5, I could just use a calculator for this, but I'll just plug in W equals 0.1 times 5, and then I get plus 3. And this is going to be equal to 3.5. So this is the one that's not true. The average blue whale at 5 days old weighs 3.5 tons, not 20 tons. Now, why are the other answer choices no good? So why are they true? The whale gains 0.1 tons per day. Yes, this is the slope, and the slope is the rate of change. So the rate of change is 0.1, and the units here are tons per day. Okay, so the weight is in tons and D is in days. So that one is true, so it's gone. The average blue whale weighs 18 tons at 150 days old. So this one, if I plug in 150, so let's just see here. We have the weight is equal to 0.1 times 150, and then plus 3. So when I multiply by 0.1, that's going to move this decimal, if I call it 150.0, to the left one. And then 15 plus 3 is equal to 18. Okay, so G is it. G is the one that's not true. The others are true. Okay, question 27. All right. So going on here, we have quadratic functions g and k are shown below. For what value of c will the graph of k be 9 units above the graph of g? All right, so this is the phrase here. 9 units above the graph of g. So that means k of x, we want it to be 9 units above the graph of g. So we want this to be equal to g of x and then plus 9. When you add 9 like this moves the graph up 9 units. Okay, so let's just fix that. So this one is going to go up 9 units if I write plus 9 at the end of the function. If I did g of x and then plus 9 like this would be left 9 units. Okay, so then all I have to do is just substitute. G of x, I'm going to replace with this piece here. Okay, so I'm going to have 5x squared minus 12 and then plus 9. Okay, so I'm making the substitution for this piece here. Okay, g of x, I'm replacing with 5x squared minus 12. And now if I add negative 12 plus 9, I get 5x squared minus 3. So the value of c at the end of k of x is going to be c is negative 3. Okay, tricky question. You got to know your transformations here. So yeah. All right. So going on here, we have another linear function. The STAAR exam loves linear functions. I don't know why, but there's a lot of linear equations here. So a customer pays an annual membership fee. So annual is like the fixed one. When I have y equals mx plus b, this is the rate, and this is the fixed amount. Okay, so each time he takes his car to the car wash, he pays only $7. So that's the rate is like the $7 per car wash. And this is like the yearly fee that he just pays once a year. Okay, so, all right. So there we go. What does the variable x represent in this function? Well, if they're paying $7 per car wash, x is the number of times they go to the car wash. Okay, so like this is like so x, just write this here in blue, is like the number of car washes. So I guess you have to go a lot for this to be worth the membership. The total amount of money the customer spends each month, no, that's y is like how much they're spending in total. The number of months the customer has been a member, no, that's not it. The number of times the customer takes his car to the car wash in 1 year. Okay, and also I should say the total amount of money the customer spends in the in each year, I would say, at the car wash. That would be y. So this one is like double wrong. So this one here, it's looking like 28 is looking like choice H, and it is. So J, we have the cost each time the customer takes his car to the car wash. No, that was the $7. Okay, this was the $7. That's how much it is. They told us right here. Each time he takes his car to the car wash, he pays $7. So choice H is the one. All right. So going on here. So now we have candy bars, linear functions yet again. And, oh, okay, this question. So there's two types. They have large boxes and smaller boxes they're getting from some like warehouse or something. So they get the large boxes. The large boxes have 24 candy bars, and the small boxes could hold 4. So you see, every time like you get a large one, so a large will allow you to fill up I'll just actually draw it out once. So 4, 4. It will allow you to fill up 6 of the small boxes. Okay, so here you could just kind of make a table. And notice that X is the number of large boxes and Y is the number of small. So X is large and Y is the small. So if you get one large box of chocolates or whatever candy bar you're selling here, that's going to fill up 6 small boxes, because 24, if I get 4 in each of the small boxes, I do 24 divided by 4 is 6. So that means two large boxes would give you another 6. So that would put you to 12. And then 3 would put you to 18, and so on like this. So now we just look through the answer choices. 1 large gets you 6 small. 2 gets you 12. 3 gets you 18. 4 gets you 24. A is already looking good. The problem with the remaining answer choices, large box, if you have 6 large boxes, that gets you 1 small box. No, that would be 6 boxes of 24 would be a big number. And to say that that's only going to give you 4, like, this is just not it. Okay. 1 large box fills up 4. No, 1 large box will fill up 6 small boxes. Okay. What they're confusing here is like, oh, the small boxes have 4 chocolates in each box. But remember, we could fill up 6 small boxes with 24 chocolates if we put 4 in each box. So that's why C is out. And then 4 large boxes fills 1 small. No, not this. A is definitely it. Okay. All right, cool. Back to something like a little bit more sane. So here, the function L equals 0.8t squares models the relationship between L is the length of a pendulum and t is the period in seconds of the pendulum, which is like how long it takes to complete like a swing. So which value is closest to the period? So remember, they told us here that the period is t. So which value is closest to the period t in seconds for a pendulum that is 30 feet long? So they're giving us L is equal to 30. So L equals 30. What is t equal to? So just plug into the equation. If L is 30, we get 30 equals 0.8 times t squared. And now we just solve for t. So divide both sides by 0.8. And now this gives us t squared equals whatever this value is. And to get rid of the square, go square root. So t equals the square root of that. All right, so let's see. So second mode, and then second x squared. And I've got 30 divided by 0.8. 6.1. Okay, so 6.1. There it is. All right. So moving on here, airline passengers pay $439 to fly to California. Oh, this is a nice question. For this price, customers may check 2 pieces of luggage. So this includes like, 2 pieces of luggage. And there is a fee of $25 for each additional piece of luggage a customer wants to check. Which function can be used to find the amount in dollars a passenger has to pay to fly with P pieces of luggage? So for this one, what we could do is P is the pieces of luggage and C is the cost. So let's notice a trend here so that we don't mess up. I'm going to show you why I'm making a table here in a moment. P is greater than or equal to 2. Because at 2, we're paying $439. Okay, if we just want to fly with 2 pieces of luggage, $439 will cover that and get you 2 pieces of luggage. But then for a third luggage, now we're paying a fee of $25. So if I go $439 plus 25, now I've got 14, carry the 1, I got $464. If I go again, another $25, now I'm at $489. Okay, that would be for 4 pieces of luggage. This is a linear function. Now, if you're not careful for a question like this, you're going to get something different. All right. This one here is a very dangerous answer choice. People might just say, oh, $25 for each piece of luggage plus $4.39. But this is the sneaky detail that $4.39 includes 2 pieces of luggage. So the right answer here is actually going to be this one. Okay, it's going to be this one. And the reason being is we are writing the equation of a line, y minus y1 equals m times x minus x1. Our slope, m, is 25. So that part is good. But our starting point is here. 2 pieces of luggage is going to cost us $4.39. Okay, like the $439 to fly to California includes 2 pieces of luggage. So when I write the equation of the line using the x1, y1, and slope, values here to plug in, I'm going to get y minus 439 equals my slope is 25 times x minus 2. The only thing different here is I would just switch the letters here. So maybe I'll just do that now. Instead of y, we're going to use c. Okay, and instead of x, we're going to use the letter p. That's the only difference here. But now when I solve, I'll just write it down here actually. I'll just get rid of that. I'm going to go plus 439 on each side. And you see what this does? It gives us c equals 25 times p minus 2 plus 439. Okay, so the way you dodge this bear trap here of the p minus 2 is just write the equation of the line and you're golden. So, all right, cool. All right, so going on here to question 32. All right, so we're making progress here. All right, 32. There are 32 founding members of an organization, and this function can be used to determine the number of members in the organization after X months. Based on this function, which statement is true? So this one, the number of members in the organization increases 9 members each month. This is nonlinear. Okay, this is nonlinear, which means that we're not going to have a constant rate of change. So 9 members each month, this is a constant rate of change. So I just know that I'm going to say rate of change like this. I just know that this one's not it. At the end of 16 months, there will be 288 members. That one is not, look, you know what though? I'm going to use the calculator. Like, why am I going to do all this mental math here? Okay. So 3x squared and then plus 32. So I'm going to go second graph. So at the end of 16 months, there's 800. So G is out. The number of members in the organization increases by 3 members each month. That's constant rate of change again. So it's got to be, yep, this is the one, choice J. So if we borrow the table and we just look, so at the end of 6 months, there will be 140 members. If we look at 6, there's 140 members. Okay, so J is it. 32 should be choice J. All right, scatter plot. So based on the scatter plot, what is the best prediction of the number of baseballs that will be used if 275 pitches are thrown? So this one here, just draw your line of best fit. So use a ruler or a student ID. 275 is here, and now I just go up to the line, and it's lining up with 100. So this question is not too bad if you know what to do. Okay, so you can see here, this corresponds to 275 pitches. That's the X. And the Y would be at around 100. Okay, and Y is the number of baseballs. Okay, so what is the prediction of the number of baseballs? 100 baseballs. That's a nice question. Nice break from all that other stuff. All right, 34. Now we're 20 questions away, and we are an hour and 40 in. All right, so we're making good progress here. I should definitely be able to do this in less than 3 hours. So a plane can carry a maximum cargo weight of 160,000 pounds. A company uses one of these planes to ship 2,000-pound containers. So if the maximum weight that could be shipped is this, and the containers are 2,000 pounds, well, the units just wipe out. 0 over 0, 0 over 0, like this. So this is going to make 80. Okay, so this tells us the company can ship up to 80 containers. So the total cargo weight is a function of the number of containers. So when they say function, I'm thinking y equals f of x. And if it's a function of the number of containers, that is the independent variable here. So when they use this language, a function of the number of containers, just think y equals f of x. So f of the independent thing is after the number of containers. So this is the number of containers. So the math I just did on the side here, though, is take the maximum weight and divide by the weight of each container, telling us the maximum amount of containers we could ship is 80. So we could either ship no containers or 80 containers, but they're asking, what is the greatest value in the domain? The domain is the set of x values. So the maximum x value here would be 80. Okay, so that would be our solution here. Okay, because once again, the total weight is a function of the number of containers. Cool. So nice question. All right, this one I'll show two ways. I'll do it by hand, and I'll do it by calculator magic. So by hand, I'm going to use substitution to solve this system. See how this one is already solved y equals? So I could say 3x equals 2 times y plus 14. Y I could replace. So you see this y, I'm going to plug in negative 6x plus 18. And now I have this. I have 3x. 2 times negative 6x is negative 12x. And then 2 times 18 is 36. Oh, you don't like this question. All right, well, I'm hoping I could make it easier for you. Just make sure you distribute just to this. Don't distribute to the 14, because the 14 is not in the parentheses. So if you want to do this question by hand, this way will work. Okay, 36 plus 14. So we're going to have 3x equals negative 12x. This is going to make 50. And now just add 12x to both sides. So 15x equals 50. So we have this. And now just divide both sides by 15 and reduce the fraction. Okay, so x equals 50 over 15. I just divide the top and bottom by 5. And then x is 10 over 3. So A. All right, a few calculator tricks to know. If you don't feel like reducing a fraction yourself, like 50 over 15, just divide and then press math, enter, enter. And there's 10/3. The other trick would be first, if I write this in standard form, so if I write 3x and let's say I do minus 2y equals 14, and then I add 6x to both sides and I get 6x plus y equals 18, I can use the calculator to do this system for me. So here, I do a little bit of algebra up front, and now I just go to, I want to say it's apps, and then number 9, polynomial simultaneous. Simultaneous equation solver, option 2. 2 equations, 2 unknown variables, and I press graph to go next. So now I have 3x, I press 3, enter, minus I could do subtract, press enter, 2y equals 14. And now I have 6x plus 1y equals 18. And now I just press graph to solve. And you see, it does everything for us. So this is a really nice trick to have. Okay, so either way, x is 10 over 3. All right. The table represents some points on the graph of linear function g. So linear, once again, y equals mx plus b. The graph of g was translated down 10 units to create the graph of h. So what I'm imagining is, let's see, the values here are decreasing. So this is decreasing. So our slope is negative. So I'm just imagining I have like some line like this, and this is g. And then we have some line g. The graph of g was translated down 10 units. Okay, so let me just draw this nice. So down 10 units, I'm just imagining like this to create the graph of h. Now, if you just slide the line down, the two lines here are going to be parallel. So just remember that. So here, if I have an x-intercept, let me just think about the x-intercept. Let's say my x-intercept is here. The x-intercept of the graph of g is 10 units to the right of the x-intercept of the graph of h. This one is like, I don't know, maybe, but not likely. If the slope were to go really steep, then I feel like that wouldn't be the case. So this one's like not, I'll put like a maybe, but like most likely not. The graph of g is steeper. No, the graphs here are the same slope. The lines here are actually parallel. So they have the exact same steepness. So this is out. The y-intercept of the graph of g is 10 units above the y-intercept of the graph of h. Yes, that is true. If I just slide the graph down 10, then the y-intercept here would be 10 above. So this one is looking good. The graph of g is less steep than the graph of h. No, they have the same steepness. They're parallel. Okay, so this one, that's going to be the idea. If you really, really wanted to, you could write the equation of the line for this. Okay, so I'll show you another trick. So here I just go stats. So let me go second mode to quit. I go stats, I go edit, and I just type, I only need 2 points to write the equation of a line. So let's say I do -4, 13. And then I do -2, 10.5. And now I go stats, calculate linear regression. So here's our line. -1.25 is our coefficient of x. So -1.25x plus 8. So we have -1.25x. And then let me just delete that. And then plus 8. All right, now I go to the table here. And let's see, these values, they should show up. So -4, 13, -2, 10.5, 2, 5.5. All right, so here's a function for g of x. And they told us in the beginning that the graph of g was translated down 10. So I'm going to show you a nice magic trick. I'm going to press alpha trace, and I'm going to write y1. And that's going to rewrite all of this. And if I want to send it down 10, I go -10. And now I could just press graph here and notice that the new graph, the one that I just graphed here in red, the y-intercept of the new graph is, I'm sorry, the y-intercept of the graph of g is the original. So the y-intercept of the original is 10 units above the y-intercept of the new one. And you can even see if I were to do the new one plus 10 would put me to 8. Okay, or you can even look here. If you want to count it, you could go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's definitely 10 above. Now we can look at the x's. This looks like 1, 2, 3, 4, 5, 6, 7, 8. So that's why choice F was definitely no good. It would be 8 units to the right. So that one there is out. All right, so 36 is definitely H. All right, this one, calculator or quadratics. I'll show both. So here, what I could do is I could graph 3x squared plus 15x. And I want to know, when is this equal to 18? The only thing I have to do here, though, when I graph this, I'm like, oh, no, I can't see anything, is I have to go to my window. Since I want to know when is this equal to 18, I need my y to go up to 18. So I'll bump it up to 20. You know what? I'll even bump it up to 30 just so I have extra space. And now I have 2 points of intersection. Second trace 5. I go in the neighborhood of the intersection. I press enter 3 times. So at 1, 18. So x equals 1 is a solution. And the only one that has x equals 1, actually I lied, is 2 of them. But it's 0 and 1, and there's no intersection at 0. So it's most likely going to be -6 and 1. But to double check, second trace 5. Now I go to the other point. Let's keep scrolling left. I press enter 3 times, and -6. Okay, so I get x equals -6 and x equals +1. So choice B. But this is an algebra test, so how do I do this with algebra? I would go -18 on both sides. And I could use the AC method again, but here I notice that each term is divisible by 3. So in this case here, I would prefer to just factor out a 3. If I divide everything by 3, I get x squared plus 15x divided by 3 is 5x. And then -18 over 3 is -6. And now two numbers that have a sum of 5 and a product of -6. So now we're factoring this quadratic. So let's see here. We have 3 times, and let's think of the two numbers. We're multiplying to a negative, so we're going to have a plus and a minus, positive and a negative. So here it looks like +6 minus 1. 6 plus -1 is 5, and 6 times -1 is this. And then here, I could set each factor equal to 0. Don't set 3 equal to 0. If you do 3 equals 0, that just looks silly, and you just wind up rejecting it. It's just like every time the constant gets rejected. But when you set x plus 6 equal to 0, this would have a solution of x equals -6. And x minus 1 equals 0 would have a solution of x equals 1. Okay, so that's why choice B is our answer, like twice. All right, this one, the graph tells a story. So let's see what story it's telling. So a factory worker packed 12 boxes at a constant rate. So constant rate means it's linear. Then they took a 30-minute break. So if they're not packing any boxes during their break, so that means we're going to have like a 0 slope or a horizontal segment. And then they continue packing boxes at twice the rate. Okay, so this means that the slope is steeper. Okay, so they're speeding up. Maybe they ate their lunch, so they got a second wind. They have energy. And then the worker spends 1 hour cleaning the work area. So they're like no longer, like, so if they spend 1 hour cleaning, they're like not packing boxes. Okay? So now let's just go through these one by one. So if we look here, see how they're going up 3 over 1. So up 3 over 1. So they're going, the scale is 3 here, so up 3 over 1. The slope would start out at 3 until they get to 12 boxes. So there's our constant rate to 12. These units here are hours. So then from 2 to 2.5, they rest. So there's the half-hour break. And then does their rate double? Well, they're going up from 12 to 18. So that's up 6 over 1. So now the new slope is 6. So this is definitely doubling the rate before. And then there's the 1 hour cleaning at the end. So F right away looks good. Let me just double check. I've been going a while now. Long day. But F is it. All right, cool. Why are the other answer choices no good? So let's see. F, G. This one, they slow down. Okay, this one is less steep. So they do have the half-hour break and the 1 hour for cleaning. And they do rise at a constant rate to 12. But their slope starts off steep with a slope of 6. And then they slow down to a slope of 3. So they slowed down. They didn't double. If the question changed to they continue packing boxes at half the rate, then this is good. All right, and then this one here, this is less steep. And also the breaks are mixed up. This is a 1 hour lunch break and then half an hour cleaning. So that one's out. Okay, so this is gone. And then this one, the work rate is doubled, but same thing. The lunch break was only a half hour, not an hour. So J is gone. F is definitely the answer. All right, moving on to 39. And oh, cool, we broke 100 people for the live stream. So thank you all for stopping by. And if you wouldn't mind, if you haven't subscribed, if you're finding this live stream helpful, please subscribe. And I would appreciate it too if you share with your classmates. Let them know, like, hey, there's a live stream happening right now, or a replay. Just if you could share as well, it would be greatly appreciated. So here we have a table that represents some points on the graph of linear function h. So linear, once again, which situation can be modeled by this function? Okay, so for this one, we could do that same technique again of going to stats. So this is a really good trick to know. Stats, edit, and just type in a pair of points. So 2 and 5. I only need 2 points to write the equation of a line. 490, 295. And now I go stats, edit, linear regression. I'm doing this so I get the entire function in case I need more information. So the equation here is negative 65x plus 620. So negative 65x plus 620. Okay, so there's the equation. And I'm going to press second graph to go to the table. And let's see if these values do in fact show up. And what else do they ask us? Well, you know what? We'll see. The equation here was negative 65x plus 620. I'm just going to borrow all of this and then see what we can make use of. So here, and we move this up. All right, this is like kind of not in a good spot. So maybe if I chop this, let's do that. Yeah, usually when I make these videos, like I do all this editing, but like I just cut this out because that's like the boring part of the video, watching me like move this stuff around. But all right. So here, now we're ready to answer. So which situation can be modeled? The cost in dollars of buying X items that cost $245 each. Yeah, that one is not looking good. Why? The cost, if you buy X items and they're $245 each, that means that this column would increase. But notice that these values here are decreasing. Okay, these values decrease over time. So our y values, I'll say the y values, and let me just make that a little neater. Just it's going to bother me to look at that. All right, so the y values, that's a little better, decrease over time. Okay, not increase. Oh, I appreciate that at Rejection Z1. I'm glad that you're finding the AP Calc videos helpful. I really do appreciate all the support from everybody. So yeah, thank you for coming by, and I'm glad it's helping your friends too. That's my goal, is to just help as many people with math as possible, and to just see how far this channel will go. All right, so thank you so much for being a part of it. It really does mean a lot. So yeah, you're all just all great. I'm not like really like the mushiest guy, but I gotta like give credit where it is. Like sometimes I just gotta stop and appreciate everybody here. So thank you for supporting. It really does mean a lot. As a teacher, I get a list of maybe a roster of like 80 to 100 students, let's say, because I teach 3 sets of classes. I have 2 double periods and 1 single period. So having like my online students as well, it just like knowing that it's reaching more people is like, very fulfilling. So thank you for choosing like those videos too. And like, I'm glad I'm able to help is like the short version. All right, so thanks. Alrighty. Let me just see real fast. So that was minus 65. Yeah, just making sure everything's in line here. So now we have the situation models. Let's see, the number of miles an airplane has traveled after flying 555 miles per hour for X hours. Yeah, that seems not it. All right, let me just read that again. The number of miles an airplane has traveled. No, the airplane number of miles it would travel would go up, not down. If we're saying it's going 555 miles per hour, that would be like, yeah, not modeling it at all. So, here we go. The remaining number of miles on a 620 mile trip. So yeah, at the start here, see at time 0, we're starting out with 620, and the number of miles remaining. So the remaining miles would go down. So this one is looking good. And they were traveling 65 miles per hour. So notice that the slope is negative 65, which means like after every hour that goes by, okay, so let me just see. I got to make this just a little bit neater. There we go. The slope is negative 65. So the number of miles on a 620-mile trip after traveling 65 miles per hour for X hours. So yeah, that one makes sense. Like if you're traveling 65 miles per hour, every hour that goes by, you're losing 65 miles off the trip getting to your destination. So this one here is looking good. And now let's see, the amount owed on a $555 loan after paying $65. This one is almost good. So this is like really, really close. This is like a good answer, but wrong. The reason being, the loan, this would be correct if the loan was $620. Okay, so if we replace this with this, then yes. But the problem is, if you're paying $65 a month for X months, this is saying after 1 month you owe $555. But no, you just made a payment of 65, so it'll be $555 minus 65, which is $490. So that's why D is out. It's like just off by a little bit. So C is definitely the answer. All right, moving on. So now we go to the inequality. So solving inequalities, which, yeah, this one has a nice trap to it. So solve this inequality for all values X when Y is 46. So first, just plug in for Y. See, Y is 46. And we have 46 is, make this neat. Yeah, at some point, I don't know if it's the program or my pen, but I use a Wacom tablet, and I think it might be on its, like, you know, I've done a lot of videos with this Wacom tablet, so I might have to finally say goodbye to it. I don't know, I guess I'm not ready to let go yet. So I rewrite the inequality down, but Y I'm plugging in 46. And now here, that's minus 2. I'm going to go plus 2 first. I think there's a nice way to do this. The minus 2 plus 2 is gone. We get 48 is less than or equal to negative 6x. I'm sorry. Let me write my parentheses. So negative 6 times x minus 18. Okay, so all I did was just add that 2 first. Now, I could distribute. You are allowed to distribute here, but there's a cooler way to do this. Ready? I'm going to divide both sides by negative 6. And now what happens here is when I divide, I get 48 over negative 6 is negative 8. But when you divide both sides of an inequality by a negative, the sign flips. Okay, so it's not going to be less than or equal to. Now it's going to be greater than or equal to. And I have x minus 18. Okay, so that's, if you multiply or divide both sides of an inequality by a negative, the sign flips. I chose to divide instead of distribute because then I just have to do one move. I just go plus 18 and now x is alone. So that was like a little shortcut. If you would rather distribute though, then, you know, go ahead. But this is style points. 18 minus 8 is 10. 10 is greater than or equal to x. And you're like, oh no, it says x. So just think about this logically. If 10 is greater than or equal to x, that means x is less than or equal to 10. Okay, so this has the same meaning. These two are like mean the same thing. So choice F. Cool. All right, we have a few questions left. This isn't too terrible. What is the zero of this? All right, we could do algebra, or we have this super calculator here. We could just write 8/3. So alpha y equals enter. You don't have to do this, but I don't know, it just looks nice. It matches exactly what's in the question. Minus 16. And we want to know, when is the equation equal to 0? What is a 0 of this? So watch what happens. We could graph y equals 0. And I'm going to press zoom 6 just so it looks like standard here. And I could trace the 0, or I could trace the intersection of the blue and the line y equals 0. So now I just get close. I did second trace 5, just showing you second trace 5. Now enter 3 times. X equals 6. 41 is C. All right, if you want to do this by hand, I don't know what's going on here. This thing is really possessed. So for this one, if you want to do it by hand, set it equal to 0. So we have 8/3 x minus 16. And now watch what happens. I'm going to multiply everything by 3. So I have 3 times 0 is 3. I'm sorry, I was joking. It's 0. I was testing all of you. Then I have 3 times 8 over 3 times x. And then I have 3 times negative 16 is minus 48. So I get here. And now 3 over 3 I could cancel. I have 0 equals 8x minus 48. And now we're going to go plus 48 on both sides. This is gone, and we have 8x equals 48. So divide both sides by 8, and x equals 6. So x equals, let's try that one more time. Yeah, this is just not writing well, but we're getting towards the end here, so we'll be able to get through. Cool. Let me check the chat. I've not looked in a while. Everyone doing all right? Oh, hello. So nervous for the exam. Well, hang in there. I know it's a lot, but remember, it's I would say, oh, it's just a test, but it's a big deal for all of you. I know. The best you could do is what you're doing right now. You're reviewing, you're studying, reviewing, whatever, and show up tomorrow and just do your best. The rest is like you really don't have a lot of control over how it goes. But just do your best. Oh, and subscribe. I appreciate that. I guess you could call them emojis, but yeah, subscribe. Thanks for advocating for the channel at Drawlings. I think that's how you're saying it, right? I hope I'm saying it right. So 42. Moving on here. All right. More questions. This is a long test. Good luck. I mean, if I'm not talking to everybody, I guess I'm just in the zone doing the test, then it like flows faster. But even so, this is a long test. Building up stamina. When did I get the 3 from in question 41? Where did I get the 3 from? Oh, good question. So when you have a fraction, so 0 equals 8 over 3x minus 16. I look for all of the denominators. There's really just one denominator here, 3. But I say, what's the least common multiple of all the denominators is 3. So if I multiply everything by 3, you see how it gave us this equation here? And the fractions are gone. So what I'll show students sometimes is like, oh, just multiply by the least common multiple, and that gets rid of all the fractions. But if you prefer to do it a different way, I'll show you another way to do it. What you could do is you could just say, you know what, I don't mind fractions. Fractions are like not that bad. Well, if you do 8/3 x minus 16 equals 0, you can just do this in 2 steps by going plus 16. This is gone, and you've got 8/3 x equals 16. And then you could just divide by 8/3 all at once. Okay, and now this is gone. And you've got x equals, and now you could use keep, change, flip. You keep the top, 16, times, and then you flip the bottom fraction like this. And now 16 over 8 is 2, and 2 times 3 is 6. So if you're comfortable with the fractions, then just do math. If you got that far and you're like, oh no, fractions, then you could just go alpha y equals enter. And you're doing 16 divided by, it was 3/8. It's going to, I don't know what I just wrote. Oh, 8/3, sorry. So 16 divided by 8/3. So I just type this in. I see I get 6. All right, or just do it by hand, either way. All right, but good question. Yeah, please, I'm glad stopping me and asking like, hey, what just happened there? So probably a lot of people have that question or will have that question as they're watching the replay. All right, let's see. So the cost of parking in a garage at an airport is $16 per day. A separate parking facility outside the airport charges 25% less per day to park. What would be the savings? So here's the question. What would be the savings in dollars and cents of parking for 6 days in the facility outside the airport instead of the airport garage? So for this one, the first thing you would want to know, what's 25% less than 16? Well, if I take 16 and I take 25% off, 25% is the same thing as 25 out of 100, which is the same thing as 1/4. So if I want to find 25% of 16, I could just multiply by 1/4 or divide by 4, and that's $4. So if the second place charges 25% less, they're doing 16, but then minus the 25%, they're charging $12 per day. Okay, so they're $12 per day. And the garage at the airport is 16 per day. So they're asking what would be the savings. Oh, so the savings is the discount. So the discount is $4. Okay, see this detail here. That is the discount. Okay, so the savings is $4 like per day. And let me write it like this. You're saving $4 per day. Awesome. All right. Does add up though. Save your money. And you save this for 6 days. So 6 days. I'm just going to leave the S off so the units cancel nicely. That's going to be you save $24 for going outside the garage. So yeah, you're saving. That's a nice chunk of change. That would scale up now in 2024, 9 years later. Probably save like, at least double that now. Probably close to probably like $40. I'd bet. All right, two functions are given below. How does the graph of P compare to the graph of Q? So this one, if you want to do it without a calculator, see how they have the same y-intercept. So think y equals mx plus b. So the y-intercept is here. And the slope is here. So as the slope moves away from 0, so like if this is like, 0, like in terms of slope, is like flat line. And then as it becomes more positive, it just gets more and more steeper. Okay, as it becomes like more negative, it becomes more steeper. So what I'm thinking of here is, all right, my slope is 5/8. But then my slope like of 8 over 5 is greater than 5 over 8. 5 over 8 is between 0 and 1. 8 over 5 is greater than 1. So this one would be steeper. Okay, but they have the same y-intercept. So when they say the graph of P has a different y-intercept, nope, that's not it. The graphs are parallel. No, this would be if they had the same slope. So if they had the same slope, then they would be parallel, but that's not the case here. So yeah, this one's out. So this one, Q, is steeper. The graph of P is less steep. That is the answer. Okay, 43 is going to be choice B because the slope is closer to 0. Okay, it's closer to 0. I wouldn't just say because it's like less than, because if I had like -10 versus -1, like -10 is less than -1, but this would be way steeper because it's like a greater distance from 0. So the more away from 0 your slope is, the steeper it is. Okay. But you could just use a calculator and graph both of these and just be like, oh, which one would I slide down faster? This one would be a steeper slide. Okay, so choice B, still correct. All right, this one, they give us a very wordy start here. The graph models A, the area in square feet of a rectangular porch. So the area of a rectangle with a length that is 0.56 W less than 28, given a width of W feet. So this is like just unnecessarily confusing because really all you need to know here is the question itself based on the graph. So this is all just like up here, like just blah, blah, blah. All right, so blah, blah, blah. All right, not that you should never read, but in this case, it's like not really important. It's just silliness. Okay, so based on the graph, what is the width? And the width is like along the X or the W axis in feet of the porch with the greatest area. So you see like the area is the Y. So the greatest area is the greatest Y value is at the vertex. So you see that's when W is 25 and the area there is 350. But they're asking you what is the width. So that's 25. Okay, the blah, 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 I will like mention that. That would be like if you want to build this yourself, then you use all that craziness up there. So that'd be like, all right, A of W equals, and they're saying the width is W, but then get this part. The length is 0.56 W less than 28. So less than means subtract, but flip. So if I'm this much less than 28, then that's 28 minus 0.56w. Okay, so if you felt like writing this function yourself, you could, but it's really like, I don't know. I think it's kind of unnecessary. I mean, just because I talked about it, like, why not now explore it? Just so we get as much as possible out of this. But if I were to graph y equals x times 28 minus 0.56x instead of w, and then I look, you see the x-axis goes up to 50. So I'll go 0 to 50. And then my y, I'll go 0 up to 450. And then watch what happens. When we graph this, it's going to give us exactly what we have here. And I can hit second trace maximum is 4. I could go before the top of the hill and hit enter. And then I go after the top of the hill. I press enter, enter again. And there's my maximum, 25,350. Okay, but like, see, blah, blah, blah. And they just give you the graph of all that. So it's kind of like an unnecessary intro. I don't know. I feel like word problems just for the sake of making it wordy. I mean, I guess it teaches you to like discard useless information. Like if they just give you the graph, it's like, cool, thanks. Then you don't have to. A really hard question would be they don't give you the graph and you got to do what I did and write the function out and then look for the max. Like that would be a hard question. Not that this one wasn't hard. It was like you had to like be able to process what was important and what was not important. All right. Question 45. The owner of a clothing store buys t-shirts for $C each and sells them. So here's something different. Sells them for P dollars. And last month, so here's some supporting stuff. The store owner, she bought 600 t-shirts and sold 500 of them and made a profit of $2,800. So let's think about this. Think about the order. Actually, we don't have to think too hard. They're saying P minus C is the order of things. Because if you think about it, if the owner sells them for P dollars each, so she bought 600 t-shirts and sold 500 of them. That means she made 500 times P because she's selling them for P dollars each and she sold 500. She bought 600 shirts. So we're going to say minus 600 shirts and it cost her C dollars to buy them. Of course, she's going to charge more to make a profit, but that's the idea. This is how much she sells for, and this is how much, she paid to buy them. All right, they were bought for this much, and they were sold for this much. All right, bought and sold. How about bought and sold so that the tenses match here? Okay, so bought and sold. All right, if you sold for 500 times P and you bought them for 600 times C, the difference is the profit. Okay, so this is the profit, and they said the profit was 2,800. So 500P minus 600C is 2,800. This one is flipped, so this one's no good. Good and flipped. So it's one of the remaining ones. Now, this month, so now second scenario. So let's see here. This month she bought 400 shirts. So the ones that are bought is with C. So she bought 400 shirts and sold them all. Okay, so how many did she sell? She sold 400. To the first equation, 600 were bought, but only 500 were sold. So here we have 400 were bought and sold. So she sold 400 for the price of whatever P is, and she bought them for the price of whatever C is. Okay, so the difference is the profit. And this month, she made a profit of 2,400. Now, life lesson out of this, I mean, I guess this is like a hard lesson in economics, is that just because she has shirts left over that she didn't sell, doesn't mean that like her best bet is to price low so she sells them all. Because notice that her profit was greater when she charged more money, even though she didn't sell them all. So that's something to think of for a situation like this. So which system of equations can be used to determine the values of C and P? Although in this case here, they're saying C and P are the same throughout. So yeah, the price she's paying and charging to sell are the same. But that is a concept. I guess I spoke too soon. So 400P minus 400C is 2,400. A is it. The problem with C is like she sold all 400, but it's like she bought one, and she only bought one. So how are you selling 400 if you only bought one? Like, where's like the 399 other shirts? So that's why C is out. Okay. How is it 25 on 44? Oh, here you're looking for the greatest area is the greatest value of A. Okay, of A. Because notice the A axis, the capital A axis, is representing the area. So it's greatest at this point on the curve at 350, but they're saying, what is W at that time? W is 25. So this question is like not terrible if you know what to look for. If you don't know what to look for, then yeah, it's worse. But yeah, no, definitely worth following up on that. Which representation does not show y as a function of x? So there's two tests you could use. You could use the vertical line test. So vertical line test. Or, so it's like this one. But in a lot of these cases, for 3 of them, we're going to use the repeating x value test. So repeating x value test. If your x values repeat, your set is not representing a function. If your vertical line, when you draw it, passes through the function, or if you draw a vertical line through your graph and it hits your graph twice, then you don't have a function of x. So here, notice the x values do not repeat. Each x has a unique y to go to. If I wrote out all of these points, should have like -2, -8, -1, -1, and so on. But if I list all of them, my x's would all be different. The only way this would be not a function is if we had something like this. We had like -2, -8, and then we had like later on -2, -1. And like, oh no, my x values repeat. But that's not the case here. The x values all go somewhere unique. So this is a function. Okay, and this is a one-to-one function, but don't worry about that for now. Which one does not show. So be careful. Don't be like, yay, function, there's my answer, and move on. You're more likely to find the one that's not. You're more likely to find a function when they ask you which one is not. So just make sure you read carefully. Sometimes when they want to be nice, they'll put it in italics so it stands out, but they didn't do that here. All of the x values are different. They do not repeat. So if the x values do not repeat, then you have a function of x. So this is out. All unique x values. So by process of elimination, it has to be this one. And notice, this one fails the vertical line test. My vertical line touches twice. It can only touch once. Okay. It fails multiple times. This is the same thing as the repeating x value. If I wrote down those points, like let's say -3, -2, comma, and then -3, -3. Those are 2 points on this graph. And if I look, when I write those 2 points that fail the vertical line test, we have repeating x values. So that's how we know J is it. Okay, so 46 is J. All right, we're in the final 10 questions. We have like 8 more to go. We are getting there. More linear functions. They love lines. So number of gallons of fuel remaining in a truck and the number of hours the truck has driven. What does the x-intercept of the graph represent? So think about this. So it's basically when the truck runs out of fuel, because the x-intercept here says after 20 hours of driving, so 20 hours of driving, there is 0 gallons of fuel in the truck's gas tank. So just think about that. 20 hours goes by, there's 0 gallons. The key here is to look at the units. The x-axis, time driven in hours. The y-axis, so maybe I'll color code here. The y-axis is fuel in gallons. So if you actually label the point 20, 0, the x-intercept, this is our x-intercept, where the line crosses the x-axis. This tells the story. So what does the x-intercept of the graph represent? The number of gallons of fuel in the truck before any driving occurred. No. That would be the y-intercept. Okay, this would be the y-intercept. That the truck started out with 200 gallons of fuel. It's a lot of gallons of fuel. All right, the number of hours the truck was driving before running out of fuel. All right, this one is good. Remember what I said. It takes 20 hours for the truck to run out of fuel, but go through the others. The number of gallons of fuel the truck can hold. That's kind of choice A all over again, just reworded. And then the number of hours required to use 1 gallon of fuel. No, that I would have to actually just write the equation of this line and then see when does the line reach 199. Okay, I would want to see how long does it take, how many hours for the line to hit 199. So that would be choice D. Oh, I don't know this. I should look that up. I'm sorry. But thank you at Drawlings for, letting people know. I'm not 100% sure. Sorry about that one. Yeah, I know like the New York rules because that's where I teach. But yeah, this I just know the math. But yeah, 50% sure. That sounds reasonable. Okay, so f of x is here and g of x is here. Which statement is true? All right, this one we could do it by hand, but I mean, why not use a calculator? We do get it. So here, how about I'll use the calculator, but then I'll verify it like by hand. So f of x is parentheses x minus 3 squared and then plus 4. And then y2 is x to the third plus 2. And where do we go? -2, -3, 0. All right, so second graph, we go to the table. This should capture all the values that we need. Yeah, this should do it. Okay. So here, blue is f of x, and red was g of x. Okay, so this was g of x. So here, f of -2 is 29. And is 29 equal to g at negative... Oh, I need more values. That was a fail. All right, g of -3 is -25. So is this equal to -25? No, it is not. So 48 is not f. F of 0 is 13. So I just go to the table, see f is here, and at 0 is 13. G of -1 is 1. These are not equal. All right, let's see. F of 8 is 29. G of 3 is 29. This is the answer. And now we have here f of 2 is 5. G of 1 is 3. Not equal. Okay. You want to see like, hey, how do you do this by hand? Something like f of -2. Parentheses make such a difference. If I plug in for x, I have -2 minus 3 squared plus 4. And this makes -5 squared plus 4. Notice that it's in parentheses. If you write this in a calculator this way, please make sure you use parentheses. The most common mistake I see is students go, so let's see. And they're probably banking on you making a typo here. Yeah, actually let me see if they do. -5 squared, I have to use parentheses and then write plus 4. Okay, if I don't use parentheses, bad news. All right, you're going to get something different. They should have made g of -3 equal to -21 to set the trap here. Okay, so this is how we would get there. If I want to verify by hand, f of 8 is 8 minus 3 squared plus 4. And this is going to give us 5 squared plus 4. Like now I could get rid of the parentheses because I'm squaring a positive. And 25 plus 4 is 29. If I do g of 3 is a positive to the third power, so I don't need parentheses here. And then I have 3 to the third power is 27 plus 2 is 29. Okay. Yeah. Even if I did a negative to the third, that's going to be negative. And then without the parentheses, it'll still be negative. But just use parentheses when you plug in negatives to be safe. Okay. So H is like definitely correct. Oh, 2 hours and 29 minutes. So I got to finish this up here. Okay. So here, which graph represents the inequality of this? So if you had to guess, this is less than or equal to. So that tells you that you are shading, but your line is solid. If it was just less than, then it would be a dotted line. But it's not just less than, it's less than or equal to. So the dotted lines are out. Got to be a solid line. Here, get it in the form of y equals mx plus b. Okay, so this, I'm going to go plus 2x on both sides. And now this cancels. I have 7y is less than or equal to. I have 2x plus 112. And now I'm dividing everything by 7. Okay, I'm dividing by a positive, so the sign is going to stay less than or equal to. And now I can write this as 2/7 x plus, and then 112 over 7. Let's see, 11 divided by 7 is 1, remainder, so 16 here. So the remaining answer choices, they have the same line. We see how it's y less than or equal to. This means shade below. Okay, so shade below, not above. So C. Okay, some people might say, wait a minute, it just says less than or equal to, so shade under? Not always. Sometimes when you solve for y, the sign's going to flip. All right. Yes, we're almost done. So I'm probably, yeah, just as excited as everybody else. Because these are, like, it does get tiring at the end. So I'm just powering through. But thank you for everybody who's stayed so long. Oh, good luck tomorrow to everybody studying right now or who's taking the test tomorrow. What is the way to remember if it's solid or dotted? I guess, well, less than or equal to is solid because a point on the line is a solution. Like, let's say I use 0, 16. So if you actually plug in, like this is your x and y, you're going to have -2 times 0 plus 7 times 16 is less than or equal to 112. And if I actually multiply this out, I get 112 is less than or equal to 112. So the equal to includes the points on the line. If it was just less than, I can't say like this 112 less than 112. This is not true. Okay, so that's why you have to make the line dotted, because the points on the line do not count as points in the solution. Okay, like that's how I remember it. Okay, but less than, under. But remember, you could always plug in a point too. Like if I plug in 0, 0, you see I would get -2 times 0 plus 7 times 0 is less than or equal to 112. When you plug in a point in the shaded section, it should make the inequality true. 0 plus 0 is 0, and 0 is definitely less than or equal to 112. Okay, so that's why it's not B. Okay, definitely C. So here, okay, this one is a formula. When you hear the phrase y varies inversely with x, that's x times y equals a constant. Direct variation, or directly proportional. Like if I say y varies, let me say, actually I'll say it in their language. So direct variation, or if they say y varies directly, with x, then you would have y equals kx. Okay, so you just have to recognize the key phrases and know the formula for this. Okay, but since they said inversely, it's this one. Okay, so x times y is equal to k. And they're telling us next y equals 48 when x equals 3. So just plug in x is equal to 3, y is equal to 48, but the product here cannot change. Whatever k is cannot change. So 3 times 48 is 144. And I know because I just looked at the numbers and the answers, but you could also do that in your head. It's not, the worst math you'll have to do. So 144 is equal to k. So now I just say x times y equals k. I plug in for k is 144. And it looks like all the answers, they solve for y. So just divide both sides by x. And you're going to have y equals 144 over x. Okay, that's our answer. Cool. All right, 51. We're in the 50s. So function k has a parent function. So a parent function is like something like y equals x squared, y equals x, y equals square root x. It's like before anything is transformed here. Okay, that's like how you go with this. You could recognize that this is quadratic and then go, oh, the parent would be the quadratic. But if you're like, hey, I don't want to do that, that's like too abstract, then all you have to do is go to the calculator and just type this in. But then here, if you do it this way, you'd have to like try out the others. You'd have to be like, oh, all right, this is like 1 over x. And this is like a exponential. So you could do an exponential, linear, quadratic. But here, I guess I know this is quadratic because the y values are repeating. There's like a turning point here. Turning point is at 0. Okay, so it's going to be like an x squared plus or minus some constant. So here, if I just do -4, -3, -1, I only need 3 points to determine a parabola. But I'll go ahead and write more. 1, 2. Okay, if you're not convinced that this is a parabola, watch if we do a quadratic regression, it's going to give us the actual formula. So 5, 5, 8. Stats, calculate quadratic regression is 5. And we get ax squared plus bx plus c. A is 1, b is 0, c is 4. So this is x squared plus 4. So x squared plus 4 is definitely coming from x squared. It's the function x squared shifted up 4. Okay, I'll press zoom 6 to put it back to normal. And if I go to the table, notice that I get all those values here. I get -420, -313, -15, 1528. The vertex is at 0, 4. Oh, I'm sorry, the Inspire. I'll be honest, I don't have Inspire, and I don't know how to use it. I should learn one day, though. You just inspired me to learn how to use it. So, sorry, I couldn't resist making that joke. But I'm sorry to let you down. Drawing. All right, so yeah, this is coming from a parent function y equals x squared. Cool. So this one we could just use the calculator. I showed how to solve a system, but this one here actually works out to no solution. So here you could solve in the form of y equals mx plus b, and you're going to see that you get two parallel lines because they're going to have the same slope. TIX or yeah, the Inspire has quite I do eventually want to learn it, but the thing is my school uses the 84 plus CE. So I would really just be learning it for fun for myself. But I don't know, it'd be cool if my school got the contract to use those calculators, like maybe like I could inspire them. Oh, yeah. I couldn't help it. Sorry, Draw. I when I see opportunities like that, I have to take them. It's just it comes with the territory now of being older, making those kind of dad jokes. All right. So here, the key with system of equations, I like to think of matching opposites. I want the coefficients of x to be matching but opposite. And even if that happens for y, just as awesome. So here, like I would like for 4x to say -12x, like 12 and -12 are matching opposites. -21 and +21 are matching and opposite in sign. So that's why I multiply by -3 to turn this into -12x. But watch what happens. -3 times 4 is -12, so I get -12x. When I multiply -3 by -7y, I get +21y equals -3 times -2 is 6. And then I've got 12x minus 21y equals -42. And now I add the system together, but watch, -12x plus x cancels to give us 0. Plus 21y minus 21y also cancels, but this gives us -36. And ask yourself, when is 0 equal to -36? This is just never true. Okay, so never true. So that means there is no x and y that makes this true. There's no solution here. Okay, the second way to see this is if you solve these for y, you would get, I'll just do this at hyperspeed, 4x, you'd get +2, and then 7y equals, this is like really possessed right now. I don't know what's going on with my marker. Sorry about that. All right, so if I solve the original, I would get 7y equals 4x plus 2. and I divide everything by 7, I put it in y equals mx plus b form, and I get this, 4/7 x plus 2/7. And then if I solve the second equation here for y, I would have something like 21y. I would add to both sides, and that would be equal to 12x plus 42. And then dividing everything by 21 would give me y equals, if I divide the top and bottom by 3, I get 4/7. And then plus 2. So notice two things happen here. I have the same slope, but my y-intercepts are different. So when you have the same slope, but different y-intercept, you have parallel lines. Parallel lines never intersect, so they have no solution between them. Okay, the system of equations where they cross is the solution. Cool, 53. 2 more to go. Almost there. Okay. So the graphs show the cost of attending a county fair on Thursday and on Saturday and playing X games each day. So based on the graphs, which statement is true? So you play 0 games, it's $10. So it's $10 to get in, and then it's a few dollars per. All right, let's see here. What's the oh, all right. For this, I'm finding slope. I see the angle. So we find the slope, and that's going to tell us how much it costs for each game. But I'm going to use nice points. Like this is 0, 10. And I'm going to pick a nice corner point here. Don't pick one that's like in the middle so that you have to bring a magnifying glass to the test. Like that would be like really unpleasant. So don't do that. Okay, so the slope of Thursday slope is 16 minus 10 over 4 minus 0. And then that's going to give you 6 divided by 4, which is 1.5. So it's $1.50 a game on Thursdays. Pretty cheap. Okay, cool. Saturday, 0, 8. And here's a nice point over here at 4, 18. So this, we find the slope. The Saturday slope is 18 minus 8 over 4 minus 0. And I don't know what just, yeah, this thing is really just scaring me. All right, 18 minus 8 over 4 minus 0. So I'm just using the slope formula here. And now I've got 10 divided by 4. Use a calculator, it's 2.5. And that tells you the cost of the games on Saturday. I'll write it over here. It's $2.50 per game. And the reason why I know the rate is this is, remember, rise over run. So the rise, the units are dollars. So you see, that's where I'm getting the dollars from. And the run is number of games. That's where game is coming from. Okay, so that's how I know all that. Now I'm ready to answer the question. The cost of each game on Thursday is 50 cents less. No, it is $1 less. Okay, so $1 less, then it would be true. That's not the case. So this one's out. A person would spend $4 more to attend the fair and play 6 games on Saturday than on Thursday. All right, well, now we got to go over to 6. And let's see, at 6, we're at 19. See, so that's the point 6, 19. Tell me I just found the slope for nothing. That would be, I think I just did. And this is the point 6, 23. So to play 6 games on Thursday is $19. To play 6 games on Saturday is $23. And now ask yourself, we run it back through the question, is 23 4 more than 19? It is. So it is B. All right, well, it wasn't a waste to do that. We'd still learn something. The cost of each game on Saturday is $2 less than the cost of each game on Thursday. No, Saturday is more expensive by $1. So this is like very wrong. A person would spend $3 more to attend the fair and play 5 games on Thursday than on Saturday. So now we go to 5. And at 5, this is like 5, like 17 point something. But then here we get 5, and it looks like almost 21, like 20 point something. So let's see. A person would spend $3 more Oh no. Well, just think about that. They would spend more money to play 5 games on Thursday than Saturday. No, Saturday's more expensive. So I don't even need to do all that. Okay, so B is it. All right, last one. Here we go. We made it somehow. All right, student council sent its members on 4 field trips during the school year. The number of buses needed to transport the members on each field trip or on each trip is a function of. So here's the independent variable. Okay, so here's the independent stuff. So when I hear y equals f of x, I say y is a function of x. This is the independent, and this is the dependent. Okay, just to use the vocabulary. So here I have my x's and my y's. See, x, comma, y, x, comma, y, x, comma, y. So they're saying here, this is a function of the number of members who went on each trip. So the independent variable x, this is like 52 people went on the trip, 72, 86, and then 105. And that's how many buses were needed after. Okay, the number of buses was like 3, 4, 5, 6. So we want to know, here's the actual question, what is the domain? The domain is the set of all x values. So if we look here, we use these curly brackets. The first x was 52, and then 72 people went on the trip, and then 86, and then 105. And now we look, and this matches up with choice H. Okay, so this is our answer. Double check that I didn't. Yep, we're good. Awesome. We made it. Oh, we said, oh, last one. Like, we just want this live stream to go forever. Actually, no, I don't know. That would be like kind of scary if I just had to keep doing these Algebra 1 questions forever. Could definitely use a break. But 2 hours and 46 minutes. So that was like decent timing. How much time do you get for the test? I hope people say 3 hours. Otherwise, I'll feel bad if I took too long. So, yeah. But to everyone who joined in here, thank you so much for, being a part of this. If you do have any last minute questions, before I sign out, I'm happy to take more like just talking questions. I mean, if I have to do another math, I'll do another math, but after 54, I'm kind of. Oh, thank you for the trophy. I appreciate it. Oh, you got 4 hours. All right, so we got an hour to relax. You get to leave early when you're done? Yeah, I think I'm probably going to tap out for the day because I've been making practice test videos for the other grades, and today I had to make a 4th grade practice test video. So that was like earlier in the day, I did a little work on that. So this is my busy time of year though, because like so many people are like getting help for math tests. Very cool day for subscribers too. Over 50 people subscribing today, so thank you for that. If it's some people here. Oh, thank you for the vote of confidence. Yeah, I'm happy to help. I like knowing like in 2024, the cool thing is like now I could teach and reach a lot of people. So, 166 people stopping by the live stream. It's like, that's more people that I teach in a day in my regular high school. So that's just really cool knowing that it's going that far. And, down the line, I hope Texas will say like, oh, you got to watch this guy, like, Vin teaches math for test review. Like I want to help, people prepare for their STAAR exams going into the future. I just hope they continue to make stuff available on PDF because I know they switched over to digital. I don't know. I really like math in paper format. Like I think they should be away from the screens as much as possible. Even though as I say this, I'm coming through a screen. But yeah, but thank you everybody for stopping by. And I'll just say, good luck. If you're stressed out, that means like it's normal. You care. I get that every year. Like people are like anxious, but I'm rooting for all of you. And, I hope you all do well. But no matter how you do, remember, it's always like a learning experience. It's like the test is just one 4-hour block of your life. People said it was 4 hours. So just, do your best. And that's all I could expect out of any of my students is like, as long as you're showing up and you're trying, I'm happy with you in my actual classroom. So my online classroom, I would say the same exact thing. Okay. So just try not to stress yourselves out too much. Try to convert that anxious, nervous energy into like test energy and just like go in there and do your best. All right. Oh, and I thank you at Drawlings for the Cash App. I'll have to, Leah, look up how to do that. That's like a cool thing. Oh, and everyone liked the stream. I appreciate that. Yeah, and seeing the subscriber count go up today was like really cool too. So thank you for being a part of that. And yeah, so good luck to all of you. All right, and I guess try to get some sleep if your test is tomorrow. So don't stay up too late. But take care and have a good night.